Good morning, everyone, and good morning, and I hope you all had a safe journey here. My colleague had a few problems in Whitefield, where we come from, this morning, but we had a safe journey, and please have a safe journey home after the presentation is finished. Please do that. So what I'd like to do now is I'm going to read some of the text, and sometimes I'm going to embellish it. So I'm not going to just keep quoting lines of text. So may I refer specifically to the relatives of those people who sadly lost their lives on the Allexander Kielland platform, who have made it for the presentation. That's you. You will be rewarded with knowing the true cause of the so-called collapse of the Allexander Kielland platform on the 27th of March 1980. But to shock you, did it really fail on that date? The answer is no. And that's one of the most important points that you need to get behind. It did not fail on that date. The presentation is entitled as follows: Explanation of finding the true cause of the Allexander Kielland oil platform collapse in the North Sea and the discovery of when it actually failed. It's a detailed review and analysis of the evidence concerning the catastrophic failure of a particular oil platform in the North Sea. By whom? By Dr. E.J. France, that's me, an experienced professional welding engineer. And what have I just told you? Everything's relevant. Yes, me. This is me speaking French. Je m'appelle Edwin James France. So that's who I am. So just to assist you all, take some water. In conveying an understanding of the information I shall present, here is an initial statement of the conclusions that tell you the true cause of the collapse. Now, the interested parties still involved with this incident are blocking your attempts at getting justice and compensation for various reasons, but mainly to prevent you, the relatives, from knowing the truth. That's what they're all up to, these blockers, I call them. The technique that these blockers are using to deceive everyone in fact, is that they are maintaining the view that the rig was in a satisfactory, well-fabricated condition when it was towed into position into the North Sea to function. Welded joints on the rig then suffered, this is what they're arguing, welded joints on the rig then suffered fatigue cracking generated whilst in service. These cracks which led to the rig instability followed by collapse. The presentation I'll give you will prove that none of these contentions have any basis in fact or truth. So what you need to know now, this is where I'm trying to help you understand the whole situation, is I'm going to give you a definition, a working definition of a catastrophic failure in a welded structure, which is what the Allexander platform is. It's a welded structure. So what's most important is Welding, welding, welding. Oh, yes, it is. The working definition of a catastrophic failure that I shall use is as follows. A catastrophic failure is where a welding component or structure suffers premature lack of function in relation to its design life. Now, the Allexander oil platform, it only functioned for 4.5 years, whereas it should function as these rigs. And I've spoken to rig managers on these types of rigs. They say it should last 25 to 30 years, no problem, before it's scrapped. So, everybody okay with that?
Yeah.
Right. Stop me if I'm going too quick. But right. Don't forget, everything's relevant here. The structure of the presentation I'm going to give you, it's in 3 parts. The first stage is a general introduction of myself, which is a who am I reveal. And this coupled with a gentle conversation with you, the members of the audience. You may give whatever information you wish when I ask you to identify yourself. Okay? Second stage is a presentation and explanation of finding of the facts concerning the so-called collapse of the Allexander Kielland oil platform. I'll tell you why it's a so-called collapse in a bit. In other words, to reveal beyond all doubt the true cause of the incident. So, please, as part of a deal to strike between us all, could you refrain from interruptions up to this point? As that actually will affect your chance of understanding the interpretation of the data. You know, that would be a tactic. If I was speaking to the blockers, they'd start to interrupt and cause chaos, you see, to divert people from the truth, you see. That's a tactic they'd adopt. So if you agree to do that, and then the third and final stage, as part of the deal we're going to strike together, we have question time, where all the members of the audience, you're free to ask any question you like. And if I knew the lottery numbers, I'd give them you, right? So do we have a deal, everyone?
Yeah.
We have a deal, right, okay. So just to repeat, everything I talk about has relevance to the finding of the true cause of the Allexander Kielland oil platform so-called collapse. Excuse me. So, the first stage of the presentation. Introduction and identification of everyone who is attending the presentation. And don't forget, this is important. This will be important to you when you use this information to try and get justice and compensation in whatever form that you desire. So, first thing, please note, I shall have to point out some facts and aspects regarding this failure that some members of the audience may find upsetting. However, I need to carry out this function of the presentation in order for the truth to be brought out into the open. So I hope you'll forgive me for that, okay? But it's important to do. One of other aspects to be derived from the presentation is to give you, the relatives, some ammunition to support your task of obtaining justice and compensation in the manner that you decide. But you need ammunition, okay? So what I'm going to start with, I'm going to give you something of my background. Now, before you got here, has anybody looked at my website at all? No. Have somebody looked at the website?
You didn't want to spoil it till we got here.
It's okay. Well, on my website, it tells you everything about me as a person and as a professional. I've been in the business of welding fabrication in industry for 50 years. And for 35 to 40 years of my career, I've been working in what's called expert witness mode, which my colleagues, I'll introduce you in a minute, but that's the way they work. And the way I get work is that companies and people, organisations, they literally ring me up and say, I've got a problem and we've got to go and sort it out. So to do failure analysis of welding structure, it's meat and drink to me, it's 24/7 activity. It's nothing. This oil rig failure just suited to me, just absolutely suited to me. So I'll just go through this just to reinforce it. I've been working in what I call expert witness mode for 35 to 40 years, and my 50-year career in the welding fabrication industry. To embark on an analysis of the so-called collapse of the Allexander Kielland oil platform is straightforward to me. It's meat and drink, 24/7 activity. I don't want to sound big-headed, but I'm a professional. You know, like when you go to the doctor, medical doctor, you want it to be professional and know what you're doing so he can advise you. Well, you come to me, I'm a doctor of engineering. You want to know what I'm saying is true, don't you? So, here's another important point. As a request from you, the audience, with regard to myself, I should like to be addressed as Dr. France. Now, this is not to massage my ego, right? But it's to give due respect to the profession of welding engineer, of welding engineering. It's an empirical science and technology. Welding engineering is purely empirical. There's nothing pure science about it at all. It's all solutions to welding problems or how to apply a welding process to something is derived from trial and error. Now that point there are people in my profession who don't understand that. They're pure scientists. And Dave will tell you where we know where these people are, don't we, Dave? We know where they are, right? And they pontificate over somebody like me, 50 years experience in industry. Well, they can get lost, you know. Well, there we are. That'll be cut from the video. So I'm going to respect the way that you, the audience, wish to be addressed. Now, the whole point of this is that you're actually witness to this presentation of the facts. Okay, you're a witness. Okay, because when you try and get when you go through the motions of trying to get justice and compensation, whichever route you take, you're going to be able to say, well, somebody's bound to say, these blockers will say, who the hell is this Dr. France? You know, he's an idiot. I think I've just been called an idiot by somebody, haven't I? A certain gentleman in Norway, haven't I? Just called me an idiot. You know, so what do you call me an idiot with no evidence? I don't mind being called an idiot if you've got evidence. But you see what these blockers do, they just say something with no evidence. So if they went into a courtroom like that and they'd made a statement in the witness box, blah, 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 with no evidence, the judge would send them to prison for contempt. So what I'll do is I'll introduce my two colleagues here. David Holden, 50-year professional like myself, consultant welding engineer. right? And he's been responsible for, if you watch the TV, equipment that's in Sellafield, which is still working satisfactorily today. A lot of that equipment Dave built. Okay, so that tells you something about him. Jeff Stott is a colleague of mine from university. He's been 50 years in the business. So, and he's a consultant metallurgist, but he's a fabrication engineer as well. He's been in the fabrication industry, not only in the UK, but in South Africa as well. Okay, so they're both very experienced. And if I say anything metallurgically incorrect or welding incorrect, they'll prompt it. Okay, so they're very experienced people to speak to. Okay, Wayne. Okay.
Oh, sorry. I'm going to introduce myself.
Yeah, go on, yeah, wait.
Wayne Hunter. Lost my dad in Kielland rig back in 1980.
Yeah, well, I'm very sad to hear that. Okay, that's fine. That's fine. That's all you need to say. Yes, that beautiful lady there.
Karen Hunter, Keith Hunter's daughter-in-law, Wayne's wife.
Right. Okay. That's fine. Yes, sir.
Derek Collins, my dad was on Irish, George Collins.
Well, I'm sad to hear that. You know what happened. Yeah. Okay. That's fine. That's fine, sir. Yes, ma'am.
I'm Deborah Collins, I'm Derek's sister.
Yes.
She's also married.
Yeah. So you're related to the person who lost their life on the rig. Yes. Yeah. I'm sorry to hear that. Yes, ma'am.
Karen Watson, daughter of John Richardson, who also lost his life that day.
Yeah, and of course I'm very sorry to hear that. Yeah. Okay. And yes, the two young ladies I met last night.
Pamela Hughes.
Yeah.
I'm representing with my uncle Colin
Yeah.
that died on the rig.
Yeah.
My mum's brother.
Yeah, I'm sorry to hear that. Yes, ma'am.
I'm Danielle Hughes, Pam's daughter.
Right. So you're a relative of a relative then.
Yeah.
Yeah. That's a fine position to take up. Yes. Yes, sir.
Tony Lamb, I'm here for my Uncle Colin, he died on the rig.
Right. Okay. I'm sorry to hear that.
Yeah.
Yeah. Sorry to hear that. That's fine.
Yeah.
That's fine, sir. Yes, sir.
Colin Lamb, my dad was Colin Lamb, he died on the rig
Yeah.
last 27th.
Yeah. Sorry to hear that, sir.
Yes.
Sorry to hear that. Okay, well that's fine. So you know that you are in future you're going to play an important role. Okay. Now, as we go along, I'm going to give you more and more information about my competence. Okay, because it's relevant. Okay. That's the slide you just had. Yeah, it's number 7. Right. So I want to give you some advice in how to think about the presentation and what you want from it. Now, what you all should be thinking now is, I need evidence of the competence of Dr. France. Quite right. Together with the facts that confirm the true cause of the collapse. So the important point here is you need evidence to identify the truth about what went on with this rig. You must have evidence. I'm going to give you the evidence. Right, so this first stage, this is about my competence. So Relative evidence as to my competence is derived from solving welding fabrication problems with equipment operating in the North Sea environment. This is the first example. There was a gas rig in 1982, I think it was 1982, wasn't it? 1982, we got involved with this. Dave and my colleague, we got involved with this. The Beryl gas pipeline is a rig 60 miles offshore from St Fergus in Scotland. St Fergus is about 60 miles north of Aberdeen. And this was a job I did in 1992, along with my colleague over there, Dave. And we got involved with, it was pumping gas from the North Sea. And obviously they laid a pipeline from the rig carrying the gas. And we got involved with the pipeline as it comes out of the sea, up the beach, across the land, and into the gas terminal at St Fergus. We got involved with hydrogen-induced cracking. Hydrogen-induced cracking in a pipe-to-pipe butt weld of this pipeline. This isn't the actual pipeline, but it is a gas pipeline. It's this weld here. That's a fillet joint there. That's a butt joint. It's that joint that we got involved with. So we'll just go back again. And we investigated this, and I'll explain to you what this is all about. But my colleague Dave there took what's called the macro view. And Dave went onto the pipeline and he went inside the pipes, I think, Dave, didn't you? Well, I was in the office doing something else. But Dave was taking what's called a macro view. I'm going to explain what that means later. He took the macro view and to cut a long story short, what was wrong with it was inadequate application of a correctly derived and qualified weld procedure. Yes, they had that. These weld procedures were fantastic. But they didn't implement them correctly. So that what actually was wrong, was that they didn't preheat the pipe properly. The procedure said preheat the pipe, but they didn't know how to engineer the preheat. And because they didn't do that, they suffered what's called hydrogen-induced cracking defects in the pipe-to-pipe circumferential butt welds. Now, I want you to remember that, because it's related to the Allexander Kielland Platform. Hydrogen-induced cracking defects. And typically, they look like this. There's your weld deposit. This is a cross-section through the weld. There's your weld deposit, there's your parent material, and you get cracks emanating from the surface and going into the parent material. That's typically what they look like. So if you can just cast that to your memory for later on. And again, this shows the offending weld, which is this butt weld here, which joins lengths of pipe together. See, to make the pipes, you've got longitudinal seams and you've got circumferential seams as well. That also applies to the Allexander Kielland problem. So if you remember that, hydrogen-induced defects as a result of the as-welded structure. Now also this hydrogen cracking phenomenon, it's not necessarily come from the surface. It can be inside the steel, but planar lamination defects in the steel, because these product forms, which the rig was made from, they're wrought, they're worked, so that the structure of the steel is got directional properties in the X, Y, and the Z direction. But that's typically what they look. These are from planar lamination defects in the steel. Well, these hydrogen cracks have come from the surface, so you can have a mixed bag of them. So that's one of the examples of what we've done. We were successful with that because we recommended slight changes to the weld procedure, these circumferential welds, and we also informed them as the kit they needed to successfully preheat the joint to drive off the hydrogen actually, and it was successful, and they got back into production. Everybody was happy. We'll leave it there because it's all obviously involved. But anyway, we were successful there. So that was a job. If I can just claim for the moment, I did for the moment in 1992. And now we come to another example, because this is pointing out other features which are relevant to the Alexander Kielland problem. So this is failure of a firefighting system on a global oil rig operating in the North Sea in 2017, and this is another job that I did when I've been operating by myself in the expert witness mode. And this is, I'll just show you the structure it belongs to, this weld. This weld that I'm going to talk about in a minute is this one here, which you see has failed, but I'll come back to that in a minute. Right, now what's wrong with this? This is a single pass weld done with the TIG process. The material is Monel 400, it's a nickel copper alloy. And it's the best alloy to deal with seawater. That's just to inform you. Now the problem here is welding a fillet weld with the TIG process without reference to a qualified weld procedure instruction. So the welder put this weld down without, he just guessed the conditions. Totally irresponsible. And as a consequence, the fillet weld quality suffered deleterious lack of fusion defects, that's no bonding. And these are unseen and undetectable by non-destructive testing techniques. They're within the volume of that weld there. Now because of that action by the welder, this is welder malpractice, deliberate malpractice. The actual structure failed due to being in use. I'm going to show you in a moment. It failed in use by fatigue crack propagation mechanism from these lack of fusion defects inside the welding joint. And just make a note of what I've just said. Fatigue crack propagation, which is cyclic loading of a structure, and the crack is moving. That is a mechanism. It's not a cause, it's a mechanism. It needs a cause to come into existence. Very important when we start talking about the Allexander Kielland platform. So, the welding malpractice, by the way, if any of you are interested in welding, the welding malpractice here is called walking the cup, which is what 90% of welders do in this country, Dave, don't they? And it is extremely bad practice. So, I'll show you now that this structure was manufactured. It's part of a firefighting system, and it sucks North Sea seawater into the system, right? This system, and it's designed to put water onto a fire in case of the fire on the rig. And when they were doing the initial trials, this has not been in, this has only been tested for, I don't know, a couple of weeks, doing a lot of testing. It's already failed, you see. There's a 4-inch gash opened up from the inside. So that what they were doing is they were sucking seawater in, and it was pumped straight back out to sea and not on the rig. Now, what if workers were already on that rig working and there was a fire? They couldn't put it out, so we got another catastrophic failure potentially happening. This is shocking, isn't it? This was in 2017. So, yeah, so it's splitting of the fillet welded joint, see that here, from only a short time in service. So you should cast this behaviour to memory if you can. So what I did there, I worked for at the time I was consultant for the firm that made these sort of things. The original firm that caused the problem was a Scottish firm. I won't mention the name, a Scottish firm. Well, after this incident, they went bankrupt. So I think you put 2 and 2 together, makes 4 there. So all this equipment was scrapped. So this would be November 2017, probably towards the end of November. And this is the situation. So they can't operate the rig. So what they do is that they put a nappy on that. I don't know, in plaster of Paris or whatever, put a nappy on it, hoping it would work. But what happened is it just blew it off straight away. Blew it off straight away. So it had to be replaced. So at the company I was working for that make these sort of systems called gimbal units, we were asked to, I was asked to, why has that failed? So I sorted that out, why it had failed. And we had to make a new one. And this would be towards the end of November 2017. And we were told by the global oil company, oh, we want this rig back in action by January 2018. So we only got 2 months, you see. So anyway, what I did was sorry to say, I keep saying I, but by the way, this is on my website if you want to look at it. So what I did was I had to resolve why the original thing failed so that I could advise the designers of this, which was the firm I was working for, as the consultant welding engineer. I had to work out why the original structure has failed and then how to build the new one. So, and the difference was the contribution I made to the new design, as I made all of these welds to be completed in 3 passes and not 1. So this is the remade item. It was assembled by welding at a company in Sheffield, and this is it. It's quite a substantial item. And to put my money where my mouth is, I fully inspected that inside and out and signed for it. And that's been in service now since January the 31st, 2018. So that's what, nearly 6 years. No trouble at all. The first one that were built didn't last 6 minutes. So that should give you a feel for my capabilities. And that's the only reason I'm telling you is I'm giving you the idea now. I am competent to diagnose what went wrong with this Allexander Kielland platform. And you see, when you start to present this evidence, the blockers are going to say, who the hell is Dr. France? That's what they're going to do. Well, that's an example of what I can do. So I don't think I'm a complete duffer, am I? Right? So, Right, so is everybody, I'm not going too quick, am I, at the moment? No, you're all right? Enjoying it, right? Okay. I like to think this is logical anyway. So, right, so now we've got to think about what was and is the Alexander Kielland oil rig or platform. I mean, during the presentation, I might call it a rig, I might call it a platform. It's the same thing, same thing. Why is it the same thing? Because it's a welded structure. The Allexander Kielland oil platform was and is a welded structure that functions as a gas/oil drilling rig and further as a floating hotel. Now, a lot of engineers, not of our profession, in industry, when they're making a welded component or structure, they say, "Oh well, it's a bridge I've made, or a pressure vessel I've made, or an oil rig I've made." Wrong. All they're talking about is function, because the reality of what these rigs are, for example, that we're dealing with now, they're a welded structure. Consequently, the most important action to be taken by the French shipyard who are building this thing in the fabrication and manufacture of the rig was and should have been welding, 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 welding. That's the most important thing. And if you don't do it properly, if I can use that word at the moment, properly, is what you've manufactured by welding, is it going to function? No. It's going to fail prematurely. It will not give you the design service life. So, one thing you can start to derive about the Allexander Kielland oil platform, was it welded properly? I'll explain what that means later on. Well, it's no, isn't it? Because it didn't function. It only lasted 4.5 years, when it should last 25 to 30 years, and no problem. And then just go and scrap it. Therefore, by definition, if the welding processes are not applied correctly by the shipyard during the rig construction, the rig will not function and be fit for purpose. It will prematurely fail and not see out its designated design life. And sadly, that is what transpired. I might be saying a few things which I hope they don't upset you too much, okay? But there's more to come, I'm afraid. Right, at this point, you need to know something. You need to know something about welding engineering science. I'm afraid I'm going to have to talk to you about it so you get an understanding. These are important preliminary statements to assist everyone listening to this presentation in understanding the true cause of the Allexander Kielland oil platform collapse. Remember, everything I'm telling you is relevant. You might think I'm diversifying here. I am not. It's relevant. So, let's ask the question, what does the word welding mean? And there's a lot of people in my profession who should know, do not know, Dave, do they? Now, just look at the word welding. It's a verb of the English language, which means to do something. So welding is about doing something, right? So that's the first thing. It's a verb. It's concerned. We've got to do something. When people talk about welding, what is it we're doing? And a lot of welders don't ask that question to themselves. What am I doing? Which is, it's people like my fault, why that happens. But the answer is, welding is the action of bonding by the atoms in component parts that constitute the mating parts of a joint. This is very important what I'm trying to show you. So if we want to, these are two pieces of austenitic stainless steel pipe, iron nickel chrome alloy, okay? If you listen to my podcast on my website, that's these two pipes making that noise. So, what you've got to realise, and I hope you do, this is an iron nickel chrome alloy, this is an iron nickel chrome alloy. But iron nickel and chrome, what? What is it made of? What are we made of?
Oh, Adam.
Atoms. Yeah. So you've got to get, if you want to produce a weld between these two pipes, you've got to get the atoms in this piece of pipe and this piece of pipe to bond, haven't you? Because if you don't get the atoms to bond, do you have a welded joint? No. Further, this 100% indisputable fact infers there's a common objective for all disciplines of the welding engineering profession, what we're all involved with, and any welding fabrication company. So I'm going to explain what the common objective is. I'll just show you what it is. So that this illustrates what the common objective is. And again, I would say virtually nearly every welder in this country, Dave, and the rest of the world, do they know it's that? No, they don't. Sorry to tell you. So what it is, this is a schematic layout. These are your two product forms there. This is your weld deposit, and this is the parent metal that goes through a thermal cycle. So to get the atoms to bond in this component and that component, we've got to do something. So you see, I'm in the welding profession. If I gave this to Dave, a very world-class welding instructor and engineer, he couldn't make them bond. So what do we need to get these two pieces of pipe to bond? What do we need? You need heat, you need energy. You've got to pump energy into the joint. So how do we get the energy in? Well, we have to use energy delivery systems, which we call the welding processes. And that's what a welding process is. It's an energy delivery system. And what happens is the welder schematically picks up the welding process and applies it to the joint. You've got to do that with skill. That's where the skill of a welder is. Physical application of the welding process. So the welding process pumps energy into the joint, that's into the atoms, so that in this case, what happens in the joint area, you go from solid to a liquid where everything mixes together, and you can mix parent metal together, and you can shove a consumable wire in if you want. So it becomes liquid and all the atoms are mixing together, intermingling, right? Then to get them to bond, let them cool down. Thermodynamics say, when you start to cool down, the atoms are scrambling about to join. Okay? So, by physical application of the welding process, the atom bonding is brought about in a way that delivers and confers to the joint the appropriate material and physical condition. That's the common objective. And that's what they should have been doing when they manufactured the Allexander Kielland Platform. Probably weren't. So you've got to generate the right material condition, which is such things as the crystallographic microstructure of and this on the rig, it's the carbon steel. And you've got to bring the physical condition to a low level as well, which is you've got to suppress crack formation. You mustn't have a high level of porosity. You mustn't have slag in there. You mustn't have your packed lunch in there either. So, and these are, you work in this direction to produce a weld with the lowest level of imperfection, which is specified in this case with the rig specification requirement, section 2, Neptune 985A. You're familiar with that one, aren't you? Okay, so in that document, which is mandatory for the shipyard to work to, it tells you how to get that condition. So, by the law of physics, right? The law of physics say for a particular joint, you've got so much mass of metal there, number of atoms, if you like. You need a certain amount of heat, energy pumped into the joint. You don't want too little, but you don't want too much, do you? You want the right amount. And you find that out when you do what's called a welding development, where you, by empirical science, you work out the procedure by which to bring that about in a satisfactory manner to deliver that condition. Everybody following it so far? So physics is saying that in welding, you've got to have a qualified weld procedure. Physics is saying that, not me or anybody else. Physics is saying that. The laws of physics are saying that. So let's just finish this particular slide. So we've recognised that we need this common objective to be achieved. That's what this should have been up to when they fabricated the rig in the French shipyard. How do we bring about the welding action and facilitate the welding joint? We'll just go over it again. To obtain the atom bonding, we must get the atoms to intermingle and give them energy, which facilitates their proximity. They come close together. And when at that point, we allow them to cool, such that they are forced to form bonds with one another. To bring this condition about is what we call welding engineering. And that's what myself and my colleagues are involved with day to day. So from where do we derive the energy for the atoms to bond and form a welded joint? We need an energy delivery system. These are what we call welding processes. You might have heard some of manual metal arc, TIG, mag, you name it. You now need to accept a truth about welding. The welding processes weld a joint, not the human being. And this is what a lot of welders in this country and in the rest of the world do not understand. It's the welding process that does the welding, because it provides the energy to pump into the joint. And that's why you need a weld procedure to work to. The welders do an important job. Welders are very skilled. I have greatest respect for them. But what they do is they bring the welding process, the energy delivery system, to the joint in the correct way. So you get the common objective condition. This is all important with regard to the rig. All right, are you okay so far? So, we need to know the required energy to get a group of atoms in a joint to bond successfully. That's to achieve the common objective. Therefore, we now need a qualified weld procedure in order to complete the task. Who physically brings this energy to the joint? Yes, what we call the coded welder. That's the person that's why we call coded welders. They work to these weld procedures. A coded welder only works to a qualified weld procedure. He does not make up his own welding conditions. So that all this fundamental requirement, when we're thinking about the Allexander Kielland Platform, right, all this information is contained in the fabrication specification for the rig. It's section 2 of a document called Neptune 985A. The document is 1,300 pages long. Well, you only need to look at section 2. All the rest of it is of no interest to us.
Dr. France,
Yes?
can I just interrupt? Can we knock this
Air conditioning.
air conditioning?
Uh,
It's cold, eh?
Wonder how you do that.
So, how is it up one?
It might be on a time, it might not. Yeah, because it just sort of tricks you.
Yeah,
Oh, it's over that.
it might just be on a timer.
Yeah, it just sort of tricks you halfway through when you're talking, so.
I'm sorry.
No, it's okay.
I'm hot and sweating because I'm embarrassed. Sorry about that.
Hopefully it'll go off.
We'll get it dealt with. It's all right for a while, yeah.
I think it's because we're directly underneath as well, aren't we?
Right, now I'm going to point out something here, which these blockers, we all know the name of the gentleman we're talking about, don't we? We've got a very appropriate surname. This is something that the blockers do not understand. There's a difference between what we call a joint and what is a welded joint. In welding technology, a joint is a straightforward geometric arrangement of the product forms. The joint is in a state condition where no welding process has been applied to it. So it's just, see that? It's a joint. It's not welded. That would be another joint. It's just how they're geometrically arranged. That's what a joint is called. It's necessary to establish this latter point to distinguish between a joint and a welded joint. As the joint, they can be welded in 3 different ways. This is all relevant to the rig. So you could weld it as a fillet weld. So where you just, if you like, it's like a superficial type weld, joining this product form to that product form. You can weld it as partial penetration, which is you're welding virtually all the way through the thickness of this, one of the components, which was a certain part deliberately left unwelded. If these joints are done correctly, there's nothing wrong with them in a sense, nothing wrong with them. Or full penetration, where you've fully fused the full thickness of one of the component points. Okay? So that's why there's a difference between a joint and a welded joint. Again, all relevant to the rig. Right. Now, is that something new I've introduced to you, that welding's atom bonding? Has that sort of blown your mind? Did you realise that beforehand? Yes, well done if you have. Right. So this is it's an electron microscope. It's a picture taken in an electron microscope, where they put in a piece of gold metal foil, which is very thin, atoms thick. Okay, but you're looking on top of it here, demonstrating the welding action. So you've got on one side, so if you're like in this gold foil, we're simulating this, aren't we? Yeah? So you've got on one side gold foil, on the other side gold foil. So when we get the atoms to intermingle and then bond, see these atoms, this simulates the weld deposits, it's a simulation of it. Get these atoms, they join to this piece of gold metal, and these atoms are joined to that. So you've got a joint. So that proves to you, in reality, you're looking at those black dots, you're looking at atoms. So if you don't get these atoms to bond to either side of the joint, so you've got nothing there, what have you got? No welded joint, you've got a defect in the joint. In the geometrical, you've got a defect. You've not achieved what you want to do, have you? Now, it's important that you realise that. Now, I just thought to show you another thing as well. Did you members of the audience, do you realise that metals are crystals? Did you know that? You did? Oh, born metallurgist.
Only from school.
But there's proof that metals are crystalline. All metals in the periodic table are crystalline. Okay? If you didn't know. It doesn't matter, but now you know. Now you know. You travelled all that way to find that out, haven't you? Yeah. So at this point in our proceedings, what should our motto be to aid understanding of the true cause of the Alexander Kielland collapse? And this is the end of the first stage of the presentation. The answer is, let's have the motto, no atom bonding, no welded joint. Again, it's all relevant to the rig. This latter condition, what it means is that anywhere in the prepared joint where we incur no atom bonding, we call such things as, we call it like a fusion bonding or cracking. What we have is what we term in the welding engineering science and technology profession is deleterious defectiveness. That is, at the end and the finish of the welding cycle, we have already incurred premature failure. The joint has failed because the atoms with these defects in are not bonded. And the strength of a not bonded situation is flat, zero. So that is, at the end of the finish of the welding cycle, we've already incurred premature failure. Oh yes, we have. Such that the welded joint, on whatever component structure it is an integral part of, it's in a failed condition. So now you can be thinking, when did the rig fail? Sorry, not in 1980. In the shipyard in 1976 as welded. Getting the message?
Yeah.
Good. In other words, the potential of the component structure, when it's got this defectiveness in it, cracks and lack of bonding, its ability to survive the required design service life is significantly reduced. In fact, it's probably gone altogether. And ever since we've been dealing with welding engineering seriously, it started just after the Second World War, when we introduced welding process in a significant way. We soon found out that because welding wasn't that good at the time, the application of welding wasn't that good at the time, nobody's fault, it just wasn't that good. That welded joints in whatever structure, components or structure, there are cracks in it, and we put it into service. It didn't last very long, it prematurely failed, it never gave the design service life. And that's one reason why that today, and has been for the last 50, 60, 70 years, in specifications for welded structures, right, cracks are not allowed. Now these weld fabrication specifications, no matter where they're written in the world, they're written in the style permitted level of imperfection, not permitted level of imperfection. And if you get cracking, it's always in the not permitted level of imperfection. So it's fail, it's reject. The whole thing, you can't use it. You've got to repair it. So, am I successfully giving you the hints about what I'm going to present to you? All right. All of that I've told you is true, isn't it? All of it is true. Do you mind if I get a drink of water? Yeah, you need to be fully conversant with what I'm telling you. So when I come to mark your homework, you'll all go through it. But you do need to be familiar with it. You will be, you'll have this information at your fingertips. So hopefully you'll agree that I've conveyed that I'm competent to diagnose what's going wrong with the Allexander Kielland platform. Okay, hopefully. But there's more to come. more to come. But that's the end of the first stage. Okay. We're in the second stage now. We're now going to deal with the nitty-gritty, the facts about the collapse, the so-called collapse of the Allexander Kielland platform. So, what is still, it has been the official line from the people and interested parties who are blocking your quest for justice and compensation. That is, their explanation, these very corrupt, irresponsible scumbags are throwing at you. What is their explanation? And these people are scum. Say that. They really are scum. The official line is, and if you look on the internet, it says, an official investigation found that poor welding and overload of column D caused cracking in the bracings, and the bracings failed, and the whole thing fell crash bang wall. That's what they say. And they argue there was nothing wrong with that rig when they towed it into position to work in the North Sea. That's their fundamental foundation of argument. There's nothing wrong with it when they took it from the French shipyard and put it in position in the North Sea. Well, I think you're already suspecting what was happening. So at this point, let me make a comment about this statement. This statement here. It's about as meaningful if one stated, the colour of jealousy is bacon and eggs. It's nonsense. It's scientific tripe. It's verbal gobbledygook. And I could use other language. So let's examine what they've said. They tripped themselves up left, right and centre. Poor welding, they say. Made the statement, it's fact. You go there, that's what it says. So, poor welds are therefore said to be full of defects, which makes the welded joint not compliant with the rig specification requirements and not fit for purpose. It was in a failed condition. So they're admitting it. They don't realise it because they don't know what they're talking about. But it's in a failed condition. Poor welding. They must have reckoned, we didn't see cracks in the shipyard. Must have done. Otherwise they say, the welding's all right then, wouldn't they? I call them scum. You know, these people have got the brains and the attitude to life of an ice cube. So, we now know it's in a failed condition. It would be in a failed condition if you say it's poor welding. Why make that statement? So then, indeed, when and where was this poor welding carried out? Oh, in the French shipyard in 1976. Wham bam crash. Therefore, their contention from the official line that there was nothing wrong with the rig when it was towed over. There was nothing wrong with the rig when it was towed into position in the middle of the North Sea. It's not true, is it? It's not true. They're telling lies to you. By their own admission. And it's by their own admission. So they've tripped themselves up, haven't they? So their argument completely contradicts itself. So it's nonsense. The blockers, I call them the blockers, claim that there was overloading of parts of the rig structure. See? They claim overloading. For this to be true, there needs to be evidence that satisfies the laws of physics, that they're making a claim for overloading. And they've got to satisfy the requirements of what's called Hooke's law, which is incorporated in Young's modulus, isn't it? These laws of physics, they demand that if your structure, your welded structure, is overloaded, you load it beyond its yield point. So you're not working in its elastic region where it can recover all its dimension and it survive for the full length of the design service life. You've gone beyond that, you've exceeded the yield point and it plastically deforms out of shape permanently, followed by rapid failure. I'm going to show you, there's no evidence for that whatsoever. None. So in straightforward language, the official line adopted by the blockers is just not true in its entirety. It's just not true. And this is what you've got to hit them with, right in their solar plexus. Wham, bam. No niceties, hit them with it. If you want me to do it, I will. And I'm now going to provide further evidence for the truth to come out. So how about that? And there's more to come. They've got more to come. But when I saw that, I'm glad I was sat down because I started frothing at the mouth in a rage. What's this? Bloody hell! What's this nonsense? And when I went to a presentation of people giving suggestions for how this rig failed. It was this time last year in Stavanger. I went there and gave my presentation, every mechanical engineer based person who had investigated the failure of the rig, I'm going to make a fool of myself here, I'm not bothered. They got up and they said, there's nothing wrong with the rig. When the rig was there, there's nothing wrong with it, nothing wrong with it. I'm not talking, that's something like this. There was nothing wrong with the rig, nothing wrong with the rig. It's all down to the stresses and strains in service. And I thought, one bloke I thought was going mad. He was bouncing up and down like this. I'm not joking. And these are the idiots that are making, having an influence on what's accepted with regard to the failure of the rig. I couldn't believe it. You see, mechanical engineers, they'd be good engineers, but what they know about welding engineering is nothing. They've no regard for the profession or the science of technology of welding. That's why they say, oh, there's nothing wrong with the welding, there's nothing wrong with the rig when I went to site. Like this, parading up and down like this. I am not exaggerating. And we know one gentleman, he was the same. So you see, do these people have a hidden agenda? Don't we? I can't say it, can I? But to keep their mouths shut. Right. So now what I'm going to do now is show you how to find the true cause of the Allexander Kielland Platform so-called collapse. So don't forget, in your mind, it is known but not accepted, especially in Norway, for welding, and they said it was overloaded. We'll come to that in a more thorough investigation of those statements in a minute. So now I'm going to start to show you how I found the true cause and how a failure analysis like myself, like my colleagues, where we work, how you find the cause of a failed welded structure. Okay? So you too can be a professional like us, but we're not very well paid, that's the trouble. So what now follows is a step-by-step explanation of how I personally found the true cause of the Allexander Kielland incident, and how a professional like myself carries out failure analysis of a welded structure. The procedure of failure analysis of a welded structure is identical to that, for example, used by forensic scientists in the police force, the health and safety executive, the way they investigate failures, and other organisations that carry out this type of work. So let's take, because it's similar, let's take the situation when forensic scientists attend a crime scene. And by golly, the Allexander Kielland Platform is a crime scene. But anyway, let's take that. They cordon off a large area around where the crime has been committed. And what we call this, I mentioned it earlier with regard to my colleague in the pipeline. This is what's called the macro view, large scale view. This should be in your mind now. We're doing failure analysis, large scale view of the subject, okay, in your mind. Large scale. And this is where they collect part of the total evidence. So if there's somebody, unfortunately, has been attacks, or shall we say, let's keep it, we only got 2 grim. Somebody's lying on the pavement somewhere, been attacked with a weapon, something like that. What they do is, you see it on the news, they tape off an area, don't they? A very large area, okay? And that's because there might be evidence in there. For example, the person committed the crime, said he stabbed somebody, he might have thrown their knife away, right? He might have blood on his shoes or left footprints, he might have left in a motor car. All this sort of evidence, right? And if somebody's been shot, it could be the shells of the used bullets, etc. And then what they do there, that's why they do that, it's called a macro view. So then, what they do then, they start to reduce the area of collecting evidence, don't they? Which is a movement to what's called the micro view. And this is what we call data collection with a purpose. Not just data collection for the bloody sake of it, which is what these judges do, right? It's data collection with a purpose. So we go, in your minds now, you've got to think, and I'm training you now to be all failure analysis, macro view going down to micro view. That's how you do it. You don't go micro view to macro view. That's the wrong way. So where are we at? Which slide number are we at now?
21.
21, is it? Right. Okay, you all right? So just pause. I'm sorry.
Reason?
I wish we could do something.
I think Wayne's ready.
Is there nothing we can do?
Why not?
Wayne to the rescue, surely.
No, it's still on.
Can't be that.
Well, when you figure we've done before, it's all got a bit more.
Not better.
Oh,
Yeah,
Sorry, one's on the
it's
one
gone
off.
off now. When we start stripping off them,
Wayne has found a new profession now, failure analyst. Failure analyst, well done. Right. So I think we're going to be able to take a break because it's coming up to 12:30. We'll be able to take a break. We're about a third to halfway through. Okay, so I think I've bombarded you with enough already. Right. Okay. We'll just continue a little bit and then we'll stop. Yes, this is still the second stage of that information. Who should carry out the data collection? Right? Well, in the police force, it's the forensic scientists, isn't it? Turn up. So we asked the question then, what is the appropriate engineering profession to carry out an effective analysis of the failure of a welded structure, such as the Allexander Kielland Platform? Well, the answer to the above question is definitely not a judge. Because judges in all these catastrophic failures, they are data collectors. They're data addicts. Data, and then they drown in it. And then nothing happens. Can I just give you an example? There's a parallel situation, the Grenfell Fire Tower. Okay. The relative organisation, for those people who lost their lives in the flats, they made the mistake. We want somebody independent to get the data together for what caused the fire. Sorry, the big mistake. Because this inquiry, led by a judge, and the inquiry into the Allexander Kielland Platform, led by a judge, but just take the Grenfell Fire Tower, it's taken them 7 years to produce data that's piled on the floor like this. And they're saying it's going to take the police force 2 years just to read it, before they can start an investigation. So that's 9 years, those relatives have got nothing, right? Right, so that's 9 years and got nothing. on the Allexander Kielland Platform, the amount of data collected, I'm going to show you in a minute, right? When I went to Stavanger last year, one of the directors of their National Archives, the Norwegian National Archives, he said, on this rig we've got so much data in the archives, it would take you 10 years just to read it. And we've got data locked in a closet somewhere where we can't open it till 2052. So, but you go back to the Grenfell Tower, so it's going to be 9 years before the police start an investigation into that fire that caused by the cladding not being suitable. Now, in the first place, when they had the fire, if they treated it as arson, a criminal offence, would it take them 7 years to get information to sort the problem out? No. 7 months at the most. So you see, the relative made the wrong choice there. Sorry. I'd have a word with them about that because what's happened with this is exactly the same. Everything's the same. I'll give you another parallel argument about this. It's identical, except that the time lapse between the data collected is about 7 years on that. On the oil rig, the data's been collected over 40 years. That's why there's so much of it in the archives. So anyway, a judge is the wrong person. A person of my profession, we're the right people. So the obvious person is an experienced welding engineer. As a professional, this description combines the necessary qualifications and knowledge base of material and welding engineering, science and technology. This is what my colleagues are here. My curriculum, BT, fits the bill, so I'm justifying I'm competent. You look at my curriculum vitae, I fit the bill. Whether I can do the analysis is another matter, but I can assure you I can't do the analysis. People involved in investigating the incident over 40 years did not possess the necessary curriculum vitae. So that's anybody, that's including the official commission, which was produced, set up by the Ministry of Justice and Police in Norway, headed by Tony Syme, yeah, right? There was none of them on that investigation committee of the suitable profession, and that's why they ended up nowhere. They couldn't explain why it failed. They haven't got a clue. That's fact, I'm afraid. So it's important for you the layman, if you like, that someone outside the welding engineering profession to appreciate this lot of requirement. That's absolutely vital. So, for example, you wouldn't have an electrician look at a medical complaint in a patient, would you? So it's derived from fact, which I'll show you about later on. So anyway, by showing you how I went about the failure analysis of the true cause, I should like to think you can be reassured of my competence. Because I don't mind you thinking, questioning my competence, I don't mind at all. It's up to me to prove to you otherwise. So I'll be 22. So, talking about this it's continued, this comment I'm making now. So, this is just trying to make you understand what I'm on about here. So, if you take note from a parallel situation of you as a patient and you go and see your medical general practitioner. So, what you do is you walk into his office and he's sat behind his desk and he examines you, okay? So, in your mind, what walks through the general surgery door is a sick Allexander Kielland Platform. It's sick, right? And it enters the GP surgery and has to be diagnosed exactly what's wrong with it, as you would as a patient with your GP. As an experienced welding engineer in failure analysis, I would regard the platform, when I look at it, that's data that needs to be analysed. Because to your GP, you're the patient, your data, and the way you express the data is in your symptoms of your illness, okay? So the rig is displaying symptoms of like an illness, an engineering illness. Now, my qualifications are in other branches of science, and I also possess more than adequate experience. I have 50 years in business. Therefore, I can claim at this point, I'm a suitable professional to carry out the failure analysis of this structure and possess the potential to find the true cause of the failure. My success be verified and confirmed by revealing the indisputable evidence that describes and indicates the true cause of collapse. So here, with that little analogy with the medical, when you go to see your medical GP, that's how I'm operating. So fictitiously, the rig walks through the door, I'm sat behind the desk in the position of the GP. I look at it and that's data to me that needs to be analysed. Okay? Sorry to put it, if you go and see your doctor now and you think, oh, I'm data, not very well. So, yeah. Right, let's do it. Right, so just run through this again now. The principle of carrying out failure analysis, especially of a welded structure, is similar to the situation of the forensic scientist investigating a crime scene, or you go to see your GP. These forensic analysts start with a macro view of the scene, that I've just mentioned, and progressively move to a more and more micro examination of the available evidence, available data. In their case, this is demonstrated by first the establishment of a large cordon, then overall general photography and gathering data and evidence, followed by going smaller like fingerprinting and blood spatter collection, and ultimately going to a more micro view, they look at DNA, things like that. So you're going down in the scale of looking at things. So the principle of failure analysis, you go from a macro view down to micro. You don't go the other way. Macro to micro. So, let's illustrate this principle with my knowledge of the Allexander Kielland collapse coming to light. What was my macro view then? It happened 40 years ago. Where do you think I got my macro view from? I wasn't there when it happened. Somebody like to have a guess?
It had to be from the radio archives and the TV and everything, wouldn't
Yeah.
it?
Oh, so you've read that then, have you?
Oh no, that was obvious though. That's why we saw everything.
Yeah. So, I never in 1980, when it was reported on the TV, I never knew anything about all this. I just looked at it as I was a burgeoning professional metallurgist and welding engineer, right? I was only 32 then. And I'm only 33 now. And so to get my macro, how I got my macro view. It starts when I remember looking at the TV programme and the film footage of all the aeroplanes and helicopters. I'm sorry if this upsets you, I'm sorry. And all the helicopters flying over the collapse rig. So this film footage I viewed on the BBC. So just to confirm it, Jan Leeming and Peter Woods were the presenters. Remember the 9 o'clock news? And this failure, this rig was in the background. You could see it, couldn't you? Okay. So that's my macro view. But you never knew anything about all this. The aerial footage, it showed you that the remaining 4-legged platform structure, after one of the legs had become detached, it was capsizing. Right? It wasn't collapsing, it was capsizing, which is a different phenomenon to collapse. At this point in time, which was the premature end of the rig's lifespan, the component parts of the remaining 4-legged structure can be observed to have retained their original shape. And they show no signs of plastic deformation, that's change of shape. Remember the laws of physics, Hooke's law? To get change of shape, to get overload, you've got to exceed the yield point. So that your welded structure, it'll lose its shape. And if there was genuine overload of the structure, it would have changed shape and crumpled like a beanbag. Like that. Not 4.5 years, but like that, if it was overloaded. So then I knew, that's my macro view, I knew the rig's not been overloaded. It's been working within the design requirements. Because there's no change of shape of the components. So what you know that from that then is that 99% certain the rig has failed by a fatigue mechanism. Okay? And that's all you can say about it at that particular time. You can't say any more than that. I couldn't say any more than that. But that's what it inferred. Where are we now? 24?
Yeah.
24. So, just excuse me, I'll go through this. I've got to say this to you. The retention of original shape, that's no plastic permanent change of shape, means it's indisputable evidence that the rig had not been overloaded. The laws of physics say so. It's not me, it's the laws of physics say so. Namely Hooke's law, which is incorporated in Young's modulus. This latter evidence now conveyed to me that the failure was likely to be derived from a fatigue mechanism that had come into existence. Notice how I use the phrase fatigue mechanism. So in general terms, so to speak, the rig can be regarded, it's a fatigue machine with the waves on, off, on, off. It's a machine, it's a fatigue machine due to the wave motion. So in 1980, when I looked at the TV, that's my macro view, I couldn't deduce any more evidence than that. And I never thought I'd be stood in front of you now making a fool of myself. So let's take the argument then. Let's take an argument, just for the sake of an argument, assuming in some way the rig had been overloaded. At the instance of overload, whenever that would have happened, the rig, in immediate response, would have genuinely collapsed. Rather like a crumpling beanbag. In other words, one would not have to wait 4.5 years for the rig to suffer collapse or capsize. It would have collapsed in about 4.5 minutes, never mind 4.5 years. In comparison, fatigue failure in a welded structure like this takes time. And it would not be immediate. This is the insidious nature of fatigue crack propagation in welded structures. So now, what I'm going to give you now, I'm going to talk about this bridge that failed in America, the Francis Scott Bridge. Remember Baltimore, where the ship hit the stanchion. You all saw that. Right. the ship, it was a container ship, hit the concrete stanchion on which the steelwork of the bridge was situated. And if you go on the internet, you can see pictures of when the ship hit the concrete stanchion, then it hit the steelwork, right? So it brought loads of stress in the steelwork. And the steelwork on top of that stanchion, it's all crumpled and changed of shape. It's been overloaded, right? And the point I'm mentioning that to you, how long do you think that overloading took to happen? In time, have a guess. 40 seconds. So you see, overload, right, happens immediately. You don't have to wait 4.5 years for a failure to reveal itself. So that's why that's that official line from these blockers in Norway, wherever, all right, when they say it was overloaded, not true, because if it had been loaded at any time in the shipyard, launched into the docks, towed to the position, if you'd have had overload, bang, it would have gone. That's a bit shocking, that, isn't it? A conclusion here is the mechanism of failure of the Allexander Kielland Platform was and is by fatigue, not overload. However, it must be appreciated, a mechanism, like a fatigue mechanism, it's not a cause. The phenomenon needs a cause to come into being, to exist. Fatigue in steels needs a defective origin. Sorry, it needs a defective origin, which is where the true cause of a failure is to be found. So wherever you've got images of fatigue on the failed rig, you've got to look for what is the defective origin that's created the fatigue mechanism to come into existence. So you see, you think of it like, say your motor car, you're into the combustion engine, it's working away, it's a mechanism working away. What do you need to get it to get going? You've got to pump some energy in with a starter, haven't you? Pump some energy in and it starts up. And it's the same with the fatigue crack propagation mechanism. You've got to start it up with something. And that's what we call, in our profession, a defective origin. Okay, it must have a defective origin. It's a mechanism, it is not a cause. And this is where you're being deceived, right, by these blockers. They're saying that for example, on brace D6, the one that fractured, what they're saying is that fatigue mechanism came into being when it was in service in the middle of the North Sea, because there was nothing wrong with it when it was towed into position in the North Sea. It's an in-service failure. So that the shipyard can say, oh, it's nothing to do with us then, is it? And that's prevailed over the last 40 years. Well, I hope you're getting the hint that that's not true. So at this stage, all right, in the investigation then, of the analysis, one has no idea where the defective origin is. I didn't know when I looked at it in 1980 on the TV. I obviously wouldn't know where the defective origin is of the fatigue mechanism that's caused the failure. So, further, it is slightly incorrect to say that the rig collapsed, as this did not occur. Getting the message now, it didn't occur. The rig just fatigued, got tired. It fractured in various places and then capsized, which is not evidence of collapse. Capsize is a different phenomenon to collapse. The term collapse, more accurately, is described as a result of genuine overload. And I hope I'm proving to you now the rig was not overloaded. So the rig was not abused by the operators. And it was working within the design requirements. Oh yes, it was. So all this information I knew about in 1980, just by looking at the film and TV footage. Why am I able to say this? It's because I'm a suitable professional to carry out failure analysis. In other words, I tick all the boxes. Let's now progress from a macro view towards a more micro view of evidence. No overload, but fatigue propagation and fracture. So it should be appreciated here that the establishment, whatever that is, Norwegian government, French shipyard and other interested parties want you to agree and accept the cause of failure of the rig was a naturally occurring crack that propagated around the circumference of brace D6. That's what they think, that's what they're saying. The fracture of brace D6 ultimately caused about the instability and collapse of the rig and produced, and this failure of the rig, brace D6, ultimately the complete fracture of the brace. This in turn induced instability in the rig and other incidents like leg de-detaching itself from the rig. It fell apart, if you like, rather like a set of dominoes, one incident happening after another. All this data then masked the origin of blame to the convenience of the guilty parties, which is the French shipyard. They've got away with it. So the cover-up exercise has been very good, hasn't it? I'm sad to say. Right, there we go. So I'm going to finish in a second. We're going to have lunch, okay? But so the macro positions that people did notice when they were looking at the wreckage, the macro positions of brace fracture on the rig are shown in red. But anyway, brace D6 failed there, but the wreckage showed that there was fatigue fractures here, there and there. And of course, see this leg that fell away, see when these fractured, it just fell away by fatigue. Just before we got to lunch, I'll just show you. So this is a schematic representation of the way the rig capsized. We see the drawings show no change of shape, and the real pictures you see leg, pontoon, brace, they've all got their original shape, so they've not been overloaded. That's laws of physics say so. So that's an actual image of the wreckage after collapse, confirming the comments of the schematic representation. No change of shape in components that comprise the rig. And we'll just finish up an interim here. We'll finish with brace D6. This is brace D6, and this is a hydrophone weld there. So we're just dealing with change of shape here. Brace D6 area, after fracture on the rig, showing the brace D6 tube still has its original round and circular shape. And the pontoon, and the leg are in the same condition of original shape. So there's no evidence of overload. See? You have a free fatigue fracture around here, you see? But with fatigue fracture, there's no macro overload at all, none. So you see, it's still got its original shape, so it's not been overloaded. So their claim by these blockers. Not true. Laws of physics say so, not me. The laws of physics say so. So, at this point, I think we'll take a break then for lunch. So, no, I think. Oh yeah, I'll just hang on. Show you other people, other engineers. And I spoke to, when I went to Norway, I spoke to an engineer who operated a pentagonal design rig for 30 years successfully. and he's claiming that brace DE, the one at the front there, brace DE, that failed first. Doesn't matter which brace failed first. Doesn't matter. When they failed, the braces, they just create more instability in the rig and start doing this. Right. And this is brace DE. See, there's a fatigue fracture at the end where it was joined to the leg. But notice, no change of shape of the tube. More evidence it's not been overloaded. See, it's retained its shape, so no overload. Do you know what the authorities did with that? To hide evidence, what they thought was evidence of failure, because they thought that's the one that failed first, you see. They melted it down for scrap without anybody knowing. Now that's a crime. Today that would be a crime. Removal of evidence, that would be a crime. So that just shows you what, the people that you're dealing with. And this is a simulation of the hydrophone valve. They do some load testing. So you see, when you overload the tube, you see, change of shape, it's crumbling like a beanbag. So there's the evidence, you see. What I'm saying is true, it's fact, isn't it? Right, so we'll finish with this. This one will have some lunch. So what have we just done? We, because we did it together, I've just proved beyond all doubt that the Allexander Kielland Platform was not overloaded. So we've trashed that claim by the official line from the Norwegian authorities. We've totally trashed it with science. Therefore, one half of the official explanation of the way the rig's so-called collapse has been found to be not true. The other half of the official explanation, the admission of poor welding, reveals it was well known that some of the welded joints were seriously defective and not fit for purpose. That was known. That's an admission of that. But you see, they're that stupid, they don't realise they've tripped over themselves. Thus, a complete contradiction of itself has taken place, and therefore trashes the contention that there was nothing wrong with the rig when towed its position in the North Sea. So we've trashed that as not true. I'm going to give more evidence to prove that after lunch. Relatives, realise what a load of nonsense the official line is. You must recognise that now. Put it another way, the walls of the blockbuster's position in deceiving you all of the true cause, they're now beginning to crumble, aren't they? Well, there's more to come, essential information, which we'll take a break there, and after lunch, I'll turn you all into failure analysis, so you can get your guns ready and away you go. Right, so we'll have some lunch now, okay? And I'll remove the no questions. You can talk to me after lunch, ask questions if you want, I'm removing that restriction from you now, all right? Right, so lunch is in the foyer as far as I know. Oh. Oh. All right, is it going all right?
Just a quick
Go on.
question. Do these people understand what a macro is?
I'm going to explain that after lunch. I'm going to explain that after lunch, yeah.
Right. There's a sample so they can understand. I was thinking, you were using the term macro quite a lot.
Yeah,
And I was thinking, do these people really understand what he's saying about macro, micro?
right, I'm going to explain that.
Understand?
Yeah, I'm going to explain that, yeah.
Okay.
Yeah,
That was just a point, that's all.
yeah. Yeah, there's a lot of information still to be,
Yeah,
where are we now? We're at slide 31 of 53.
yeah. It's just a point of struggling. I was thinking,
Yeah.
you know,
But you see, what will be interesting is, when I finish the presentation, will be the questions they ask. That'll be interesting.
yeah, yeah. All right.
Right, I'm just going to get something from the car.
All right, Jeff?
Yeah. He needs to present his slides better than he does. Let's go from large font to tiny font. Needs to be sorted out.
Yeah.
That'll be reducing the number of words.
I don't know where this is.
It's supposed to be in where we have the copy.
Yeah.
I think.
That's not
Yeah.
Don't forget, there's water if you...
I am saying just.
Thank you. And that came on before.
I was sitting there and getting, my eyes were watering. Oh, that was my eyes was watering.
Should have that whole thing in, yeah?
Hi.
Doesn't it want it expands?
Yeah.
By pound. So there was a whole month. Right, so
Your fingers are so somewhat freaking out.
sometimes.
Operation, make an incision down here. And,
Shall I close the door or?
hand.
Yeah.
Or are you too hot now?
All right.
Shall I close the door on you?
Oh, no, that's it. Small incision.
You see, an oil rig might come, it's sick. An oil rig might come through and you're going to have to feel and analyse it, you see.
Take the seat.
Oh, I'll talk you. Yeah. And I hope you enjoyed the lunch. Hope you enjoyed the lunch. I enjoyed it.
Yes, it was nice.
Yeah, okay.
Good variety.
Right. Right, more to come now. Again, a little bit more sort of like technical and scientific, but I hope you agree that I'm putting it over so you can understand it. Okay, right. We're at junction 32. There's 53 slides, so you'll know. About 3 minutes a slide. And so we now have a feel for the macro view, because you're all turning into failure analysts now. The macro view can tell us about the so-called collapse. But what happened after the collapse, the so-called collapse? Yes, after those tragic images were caught on camera by the media of the time. So, at least for once, we can say for the TV, they took the pictures of the rig when it had capsized. Well done, at least we've got that evidence, that evidence can't be destroyed. Right, Now, the Alexander Kielland oil platform was said to have officially collapsed on the 27th of March 1980. Then on the 28th of March, the day after, the Norwegian Ministry of Justice and Police appointed by royal decree a commission to investigate why the catastrophic incident occurred. Presumably you're familiar with some of this, are you? Did you know that was the day after they appointed a commission to look into the failure? Yeah. Well, it was the Ministry of Justice and Police. The commission was headed by Judge Thor Nisheim of the Norway, this is in Norwegian, the Justice Department. And he was a judge. He sadly passed away, I think about 15 years ago. But he was a judge. And the other parts of the commission, they consisted amongst others, a professor of marine engineering, who will know nothing about welling engineering, absolutely nothing, and the two rig operators. They didn't have suitable experienced metallurgists, and they didn't have suitable experienced welling engineers at the time. They never used them. I shall point out later that the commission team did not contain suitable professionals required to correctly interpret the harvested data. So they were harvesting data. In March 1981, the commission published its report in the Norwegian and the English language. And it's from reading this latter report, anyone can carry out a failure analysis, because that's really your access to information, to data. So that was the position I was in. It's from reading this report, anyone can carry out the failure analysis, as the commission team did harvest relevant data as to the nature of the cause of failure. So it's to their credit that they harvested this data. They did. But one needs to be capable of identifying, finding the critical data and interpreting it, which they weren't able to do because they didn't have the suitable professionals. They didn't have the suitable professionals to interpret the data. So, derived from trying to analyse the harvested data, the main conclusion of the commission as to the cause of the collapse was that a crack had propagated around brace D6. You're all familiar with brace D6? Yeah. At the hydrophone insert position. This latter crack led to the brace D6 fracture. The rig subsequently became unstable and leg D detached itself from the rest of the structure. The remaining four-legged structure then collapsed. I say collapsed, but it capsized. It's different. This version of the cause of the Alexander Kielland has persisted for over 40 years. I think you'll all agree with that? Yeah. So where are we now?
32.
32. So now we are talking about my investigation, how I found the true cause, how I went about it. Now all this information was available to me before I embarked. Well, it wasn't available to us. Yeah, sorry, it was available to me before I embarked upon my failure analysis exercise of the Alexander so-called collapse, Alexander oil platform collapse. But how and when was I introduced to the subject? of the Alexander Kielland oil platform failure. How was I introduced to it? So you know that in 1980 I just saw it on television and I thought, I'll never be involved with that. Well, it's obvious I didn't start my analysis in 1981, did I? So why did I start my analysis of this incident in 2018? That's when I started looking at it, which is over 40 years after the collapse. The time gap, it doesn't matter, providing evidence still remains. So if it still remains, you can do a cold case. You know, there's a TV program on it, in the cold cases. Providing the evidence is there, they can solve the case. So in 2018, in order to add to my existing extensive welding engineering and expert witness job knowledge, I made use of some spare time to research famous welded structure failures. When you do commence this type of research, one immediately comes across the Allexander Kielland platform collapse. It's all over the internet. And so I pursued with my task based on this failure, so I used that. For my analysis, one had to find the Investigation Commission report in the English language. But you must recognise the problem of nuances of language derived by translating from Norwegian to English. So there are problems there with scientific terminology, going from one language to another. When one reads this Commission report, it soon becomes apparent to any self-respecting metallurgist, welding engineer, that the members of this team, the original Commission team, did not originate from these latter professions. It's obvious, blatantly obvious. I'm afraid to say the scientific content of the report by the Commission, it was naive and inaccurate in every sense. I could use other words to it, like they might as well publish some nursery rhymes for what it's worth. Worthless from that point of view. But to their credit, they did harvest the crucial data, which is to their credit. Realising the serious flaw in the report's explanation of the true cause, I decided to carry out my own failure analysis, and that resulted in this paper that I produced and had it published in a prestigious journal in the United States in 2019. And this is so you must understand at this point, I knew nothing about all this. Got nothing about all this. I just wrote, if you like, a pure scientific paper on failure analysis. Okay, that's what it is. So it doesn't go into the detail, some of the detail I'm giving you now, because it's not relevant to go into a scientific paper like that. But it does contain the basic elements of the true cause of the collapse, which they didn't work to qualified weld procedures. But there's more to it than that. So this report, it's just excuse me while I get my glasses. Yeah, here we are. So I'll just read from the abstract. This is on my website, by the way. And this is an excerpt from the abstract. The objective of this review regarding the catastrophic failure of an important welded structure, the Allexander Kielland Platform, was to indicate that the investigation team should have comprised and involved an experienced welding engineer. Lack of involvement of the welding engineer can lead to misinterpretation of the evidence, which results in the incorrect identification of the cause of failure. That's in the abstract of this paper. And currently, this paper, if you go on the website and look at it, this had over 14,000 downloads from university research departments, fabrication companies all over the world, research students, governments, and refer to this. and it's had, it says on the internet, it's had 30 scientific citations of truth. But if you look at another part of it on the internet, it says only 15 citations. Well, there's a catch-up situation. You've got to catch up with the citations. It's had 15 citations of truth. And we've got somebody that we know with the appropriate surname in Norway, he tries to trash this, doesn't he? You know, but this is accepted all over the world. It's accepted. Citation number 6 it's in a paper written by a very important scientist in the oil and gas industry, and he's written a paper on the effect, the footprint of the oil and gas industry on the climate and the environment. And he cited this paper, and he's saying, well, we don't want to build an oil rig as bad as that then, do we? See? But this, you know, these blockers in Norway, they still try and trash this. This is accepted by, you know, scientists all over the world. So what are we dealing with these blockers in Norway? How can they take that position? But it is there's some, what I'm presenting today is not included because it's not relevant. It's a pure failure analysis paper. And you can go on the internet and just download, print it off if you want. It's free of charge. So anyway, I had to use that commission report to do my failure analysis because there was only access to information that I had. So we're at 33. So the result of my failure analysis of the evidence, the data, contained in the commission report led to the publication of my findings in a paper published in the Journal of Failure Analysis and Prevention in the United States in 2019. So this is evidence that what I'm saying is true, right? When you use this information to try and get justice and compensation, you reference this. Make a note here, at the time of my research and writing of this paper, I was unaware of the cover-up, corruption, relative situation regarding justice and compensation concerning the collapse. I knew nothing about you at all in 2019. The title of the title of my paper is what it says there, and to date it's received all these accolades expressing that it's what is published in there is true. And I wrote the paper in a purely scientific mode, completely unaware and untouched from the politics, injustice to relative corruption, cover activities. It was a standalone failure analysis paper. The paper, though, it reveals new evidence for the true cause of the rig collapse. When that evidence is examined forensically by the appropriate expert and professional, that's me, one can now establish that the Commission, to their credit, did harvest the critical data, as I've just mentioned. However, they were not able to interpret this data correctly, which is not a derogatory remark about the Commission, but understandable as to their weakness in the team makeup. The team did not contain suitable professionals for the detective action. And I pointed out to you that the latter point is in the abstract of the paper. To understand where the cause of the Allexander collapse can be found, one just references the microphotographic evidence of the fractured brace D6, which is figure 2 in the paper. Well, by saying that, I'm not saying that the failure of brace D6 is the cause of the failure of the rig. What I'm saying is, if you look at it, you can find out what the cause is, right? This is harvested by the harvested data by the Commission they concluded that it is fatigue fracture, but never question why it exists. You got to question that, and that comes from your macro view. Why is it there? Which you need to determine to find the true cause. So now we've looked at the earlier pictures where I showed you there was no plastic deformation of the wreckage, if you remember. Do you want me to show you that again?
Oh,
No, you're all right with that. Yeah, so that was the macro view. So now we're now going macro, we're starting to go micro. So despite the size of this thing, we're going micro. So it's a micro photograph of the fractured brace D6. But from here, we're now taking the direction of a more micro view of the evidence. In other words, we are tracking down the defective origin of the fatigue mechanism that brought about ultimately the collapse and capsize of the rig. At this defective origin, we'll find the true cause of the collapse. So just from looking at that, we're not saying that actually brought the rig down when it fractured, but the information therein, right, will tell you where the original failure was, what it was. Now, if you read the commission report in the English language, what I'm saying to you, to be critical of it, it harvested the data, but the written text, they might as well submit industry rights. It's nonsense. Because the person writing it, one was not a metallurgist, and the other wasn't a welding engineer. So what are you going to get? Verbal gobbledygook. But to my colleagues here and to myself, this is data in terms of photographs and diagrams in the commission report. That's talking to us in welding engineering language. When I'll tell you this now, it's no exaggeration. When I showed this photograph to my colleague Dave, within a minute he knew the cause of the failure of the rig. And I'm not joking. He did. Because it talks to us. It's talking to me now. All right, so that's why I can do a failure analysis, even though the commission report is that you might just throw it in the bin. But this is important data. So what we're going to look at is this hydrophone weld as an example of trying to find the true cause of the collapse. Okay, that's what we're going to do. We're going to examine the welding engineering information that's there. This is all in the report. So at the hydrophone insert weld position, right, which was fillet welded. You know, there are three ways of building a joint: fillet, partial pen, full pen. It's welded, fillet welded, and the fatigue fracture. It needs an origin, something, you know, like starting your motor vehicle. It needs an input of energy to get it going. And when you look at the fracture surface of the fatigue crack, in other words, what's that surface all the way around there, which has just got classic fatigue fracture of a carbon steel. What you see is these are called chevron marks. See? Curve marks. And they all point back that way. Use my hand. They're pointing back to the defective origin. And here you can see that the hydrophone weld has been fillet welded. Right? So a fillet weld, there's no welding in that area there. Okay, are you with that? Okay. So what have I said there? Actual fracture surface features related to the circle position on the schematic. That's here. Confirming fatigue crack propagation mechanism was operating. Chevron markings point back to the defective origin, which was, yes, the fillet willis joint. Now, Jeff is a 50-year professional metallurgist, studied fracture. What I've just said is true, is it not? The chevron marks point back to the origin.
Can I correct you?
Go on.
Those are not chevron markings.
Well, but,
Those are beach marks.
right, well, for a beach marks, yeah.
Yeah.
That's terminology.
No. The point is just make it correct. Just make it correct so that the rest of the speech is okay.
Yeah,
And basically, those are what we call beach marks. And the reason why they're called beach marks is from about 200 years ago, the engineers has recognised this particular pattern coming up on fractured shafts and what have you. But I had no idea what to call it until someone was walking down the beach where the waves come up and then recede. And he noticed that there were several markings which looked identical to those. So
Right.
that's why they're called beach marks.
right. Well, I stand corrected.
Chevron markings they point back to the arrowhead points back to the origin. We were correct there, but those are beach
Yeah.
marks.
Right.
That's
That's all right.
Carry on.
So you see, you've got a third party, you see, correcting what I just said. Well, basically what I have said is true. These markings, if we could call them that, in the report they call them chevron markings. Right, which Jeff pointed out the incorrect nature of that. But it points back to the source, which is the defective fillet load.
So they both mean the same.
Essentially, yeah, both do the
It's
same,
more
yeah.
the method
Yeah.
rather than the
Yeah,
name.
what
of
you
it.
see, you've got a safety valve here, that's okay. So this is, when you're at university and you study this, right, the science of metallurgical fatigue demands a defective origin to start the mechanism of crack propagation. So you see, the way the schematic, they teach students, you need an origin, fatigue origin, then you've got the beach marks, see, and then you've got the overload position. Okay, so when you're studying fatigue, that's what they teach you at university, based on fact, obviously. And to simulate how the hydroform well failed, right? This is perfect to describe how the hydroform weld failed by fatigue. Right, so this illustration simulates quite effectively the way the brace D6 suffered its fracture derived from crack propagation mechanism at the hydroform insert position. So it's this type of cam where you've got a weld all the way around the lid, so there's a weld all the way around there, and you have your little cap tongue there that's pressed down. So to open it, you flick the, what do they call that? Tang or whatever.
Wrinkle.
A ring pull, right? Just so that's a ring pull. So you flick the ring pull up, so you pumped in a defect. So you're starting it up, right? That's your starter impulse of energy. And then you put put my finger through there and you start to fatigue it. So it's load on, load off, load on, load off. And what you're doing is, the crack in the weld is going round the circumference. And by the time you got to there, you can just whip it off, can't you? So if we go back to go back to that. See, if you go back to this, see, that's represented by the schematic, you see. The crack is, the defect is introduced to the fillet well there. And then due to wave motion of the, on and off the rig, it propagates a fatigue crack around the circumference, and roughly when it gets halfway around, there's not very much of the steel, you know, thick rim of the tube left to take the load. It's massively down, taking the full load, so it just rips off. And to confirm that, in the reports that you've had a look at, Wayne, the people working on the rig, they might have been having the bacon and egg in the canteen, and they said, I heard a massive thud, didn't I, and bang. Right. Well, when this fractures, and this is rapid, it will go with a massive bang. And that's due to the creation of surface energy. Sorry to bother with thermodynamics, but that's due to the surface energy release. But you see, some of the investigators, they're looking at this. See, a lot of the early investigators have published papers. What they've done is, they've gone straight to the micro view. They're not bothered with the macro view. So they've never asked the question, why is that fatigue crack there? It shouldn't be there. See? So you got a little lip here, right? Now, go back to one fire night and you made some treacle toffee and you pull the treacle toffee out of the tray and it leaves a spike like that, doesn't it? So this, even though it's steel, that's how it's behaved, like treacle toffee. And it goes with a massive bang, which is what they reported, the people working on the rigs that survived. I said, oh, there's a massive bang when I was having my bacon and eggs in the canteen, you know. So that's how that failed. Right, so we can get now information now, which gets to the nitty-gritty now about the true cause of the collapse. Because just examining this hydrophone fillet well here, where did that defect origin come from? Why was it there? Because it's a question worth asking, that. Because why we should ask that question is, look at this weld here, the drain hole. That drain hole weld is the same joint, not welded joint, it's the same joint as the hydrophone weld. Well, there's no fatigue cracking coming from there, is there? It's even survived the forces when it collapses. It's even survived that. Well, this joint, it's the same joint. It looks different in shape, but it's a set through branch joint, right? Not welded joint. Set through branch joint. That's the geometric arrangement. Even though it's rectangular in shape, that doesn't matter. It's the same type of joint. That's been welded with a qualified weld procedure, qualified welder. And it's been visually inspected according to section 2 of the rig specification, Neptune 985A. So it just shows you, if welded joints on the rig were welded to the specification, would we have had other welds that failed for fatigue? And the answer is no. But you see, there are other penetrations. What do you think that is there? That's a penetration into the tube. Must have been welded correctly, but there's no cracking, fatigue cracking emanating from that because it's been welded incorrectly. So the rig was a mixed bag of some of the welds welded correctly to the spec, others, like the hydrophone joint, no, not welded to specification. So the drain hole was welded as a full thickness the full thickness joint through the full thickness. Whereas the hydroform weld was only welded partial thickness because it was just a fillet weld. So, let's just look at some more information now, which is, we're going to the telling information now. Right. Now, what some very astute person did I'm going to tell you something in a way that perhaps you wouldn't know as actually took place. But you remember when the director of the National Art Museum, Elsa Tungland, paid a visit to the UK? Right, she might have visited you, right? Well, she interviewed myself and David Holden in New Brighton, wasn't it? In New Brighton. Did you know about that?
Yeah, it was. I think it was the day before.
Right.
Yeah.
Right. Yeah. So Elsa Tungland, who's the director of the National Art Museum in Stavanger, she came over. This would be about what? 2 years ago.
2 years.
About 2 years ago. And and myself and my colleague Dave Holden, we met her in New Brighton Hotel, and she came along with one of her colleagues as well, and she interviewed us. And we mentioned to her about the poor state of the welding on the hydroform weld, for example. And she said, well, I've met the person who has taken macro sections of the weld that still remains. You see, it's still attached to the tube brace, yeah? The fillet weld that's going around the circumference, it's still attached in places. And she told us she met the gentleman that did what's called, she took macro sections. Well, do you know what a macro section is of a weld? No, X-ray. Yeah, well, what you do is you cut through the weld and you polish and etch it at a position in the weld length. And he took three macro sections on the circumference. Okay. So she told us that was actually true because she'd met the bloke that did it, and it's indeed fortunate that he did. So he took macro section from the remaining circumference of that fillet weld. Okay, so that it's in 3 positions. This is the insert tube, that's the brace. Okay, so that there's a fillet weld either side, on the outside and on the inside, a fillet weld. Yeah, can you see? Yeah?
Yeah.
Yeah, unwelded portion, fillet welded portion in 3 positions. Right, now we're getting to the nitty gritty now. First thing to notice about that, that's the original weld from the shipyard in 1976, isn't it? Yes? And what do we see? A hydrogen-induced crack. Do you remember what I told you about the beryl gas field? There it is. It looks virtually identical, doesn't it? It's hydrogen-induced crack. And don't forget that this crack, right, it's not associated, it is not associated with the fatigue crack that goes round the circumference. It's not associated with that. This crack, you see, it's in the pipe insert, it's in the pipe, it's not in the fracture surface that's been created. originated, it's in the pipe, so it's as welded. So there you see, there's evidence that some of the welds on the rig, 100% indisputable, they're in a failed condition. Because in a crack, are the atoms bonded? Because in a crack, you open up a crack, there's a surface of atoms there, there's a surface of atoms there. Are they bonded?
No.
No! So it's in a failed condition. It's not welded together. It's in a failed condition, right? Have I got across to you what a failed condition is?
Yes.
It's not a failure, an outcome. It's in a failed condition. Okay? This is the way you're going to have to argue, right? Okay. So that was the staggering information that you could glean from that. The Commission had no idea what that meant at all. And my colleague Dave, he's actually had a look at the welding of this fillet weld. And it was designated as a fillet weld by the designers in the French shipyard and the French management. It was on instrumentation. A fillet weld will do. It's not highly loaded, you know, so 10mm fillet weld will do. Now, the report says they used, was it a 5mm electrode to do that joint, didn't they? And to do the fillet weld joint, you'd have to weld it in this position and in that position, all right, to do it. Well, the welder was given a 5mm diameter electrode. And now in the monumental art process, that is a crowbar. So they were asking the welder to do lace work with a crowbar, if I can paraphrase it like that. So, you see, all of these waves, these lines, right, this is not a multi-pass weld, it's just one weld. And the welder's been doing this, fighting it, you see, because a 5mm electrode, it's operated at about 250 amps, 30 volts. You could flood like Old Trafford with it, you know, and there's massive weld metal there. And when he gets to the overhead position, if he's not wearing protective gear, he's dead. Right. Because if the liquid metal drops on your jugular vein, you've had it. So everything's wrong about this. Now, other reasons why this is wrong is because, we'll go back to 35. Now, to make this tube for the brace, what they do is they roll plate in a circle. And then you've got to do a longitudinal weld to complete the circle. And then you've got to do circumferential butt welds to increase the length. So let's just remind you of that. Okay, so to increase the length of the tube, you got to do one of these. So you got to do, see the longitudinal seam welds there, see? Roll the plate, longitudinal seam weld, which is full thickness, and this is full thickness as well. So if you want to put a branch into that, you've got to cut out a hole. Now this hole is quite large. Give the dimensions of it. See, this hole to put the structure into is what? 325mm diameter. OD. So if you cut a hole in that brace, that diameter, before you do anything, before you insert a pipe into it, right at all, that hull, what is it? It's an enormous defect, isn't it? Right, and you've removed steel, which is going to be should have been carrying load.
It's weakened the structure.
Correct, it has, yeah. You know, won't fail analysis. Won't fail analysis. So, yeah. So the selection by the management, the designers in the French shipyard, maybe the well in supervision, that this fillet weld is acceptable, is ridiculous. That's an excuse not to do what you should be doing. And it's incomplete, irresponsible, non-compliance with the rig specification. It borders on a criminal offence. So, for that particular reason, that the brace tube is made with full thickness welds. If you want to put an insert into it, a joint where it's a set through branch weld, right? Set through branch. It's not welded yet. Set through branch. You have to weld it to recover the area of steel that's going to take the load. So, does a fillet weld take the load? Has it got a big enough area of strength, for example, to take the load?
No.
No. So it's going to be more vulnerable to cyclic loading, isn't it? So now we've proved it's not suitable, the joint being welded as a fillet. Let's go back to our definition of welding and welding engineering, right? And atom bonding. So it's the wrong joint. So there we've got a massive area of no atom bonding. And what's our motto? No welded joint. But see, I'm afraid the Commission didn't have the people to realise that, I'm afraid. So you can start to see now, you know, where the original failure is. So, right, so some more information now. So, you're okay with, these are macro sections, you understand with that? You okay with that? They are instances in time along the length of a weld. What happened? And this evidence, you know, is 100% indisputable. You know, that as welded, that weld was welded in the shipyard in 1976, and it's incurred hydrogen-induced cracking. This is not fatigue cracking, this is hydrogen-induced cracking. Because they haven't used a qualified weld procedure. Sorry?
It's the wells that follow the paint, or some paint or something found inside the cracks.
No, I'm going to explain why they found paint in the cracks, yeah, in a minute, yeah. So, this is just one piece of evidence, the way that they welded this, the cracks, it's one piece of evidence. They didn't use a qualified weld procedure yesterday.
Can you just point out the other defects that's showing in that weld? Besides the crack, there's other defects in that weld.
Yeah, there is, yeah. Lack of fusion.
Yeah.
Lack of fusion.
But there's also lack of fusion on the face of the lower picture.
Yeah.
Is that then the
Yeah.
curve with two
Yeah.
lines that you said about
Yeah.
before?
Now go back to your atom bonding now.
Right. Can you see it? Yeah.
Yeah, there's no atom bonding, yeah?
And that's all, that's all because of the size of the rod.
Yeah.
He was too big to get the fine.
Exactly.
Exactly. You're all turned into welding engineers, I think it's great. Well done, Wayne, well done. I'm not joking, great. Because a lot of people who should have appreciated that didn't. So that's very damning evidence, but from the point of view of the defective origin, these macro sections have been taken from the original weld in the shipyard. So deleterious defectiveness was as welded in the shipyard. So it's in a failed condition. It's in a failed condition, okay?
The shipyard.
So That's a picture of the weld before it went to sea.
Correct. Yeah.
So it failed before it even left the shipyard.
Yeah, well, yeah. It's better to, at this point, let's just leave it at failed condition,
Yeah.
right? I'm going to explain a bit more later on, right? Okay. But anyway, good that you questioned it. You in question time, you have a go. You have a go. It's no problem. So.
I didn't realise that was a picture of the wells.
Right.
Went to sea.
So I've just given you a lot of that damning information, just to be gleaned from that hydrophone weld. And please remember, when I'm not saying, nobody can say that brought the rig down. You know, brought the action of the you know, the leg falling off and the crash bang board. You know, I'm not saying that at all. It's just information you can get from the way that particular joint was welded, because there were other joints there that were badly welded. The divers found that when they went inside the tubes, when it was drawn back into the fjord, and they went down inside, the welding was even worse in there. But we're talking about now information which proves beyond all doubt this failed condition in the shipyard. And we come to probably the most important point about the whole investigation is the significance of the most important harvested data by the original investigation team. They found paint inside the hydrophone joint. See, paint here, you see. Maling in Norwegian is paint. And this is the inside of the joint. See, that's the inside. But also, look, there's enormous bloody gas holes in it as well, which is yet evidence they never preheated the joint. So they've not used the qualified weld procedure. The specification in section 2, rig specification, Neptune 985A, says you've got to preheat the joint. And one is to drive off all the moisture, which is the source of the hydrogen-induced cracking. So this is damning evidence. Now you ask the question, how the hell did that paint get in that joint?
Because the joint that failed.
Good, I'll relieve you from interrupting. Go on.
It must have already been there when the painted.
Yeah.
No.
No?
No. No.
Fracture.
No. So anyway, let me just take you through it, right? Okay. Fine, that's fine. Yeah. Question time is going to be very important. All right, okay. So this is a macro photograph taken by the commission, taken from the exposed fracture surface position inside the welded hydrophone joint. Painting of the hydrophone insert joint was carried out after welding. And so how did liquid paint manage to get into this position? Well, we've already seen in the as welded condition, we've already seen, see this crack emanating from the surface going inside. We've already seen that as welded, if you just painted on top of it, the paint would go inside the cracks. Right. Some people might argue, oh well, the steel component parts, they were painted before they were welded, so all the component parts in the shipyard had a protective coat of paint on it. You see? This is painted before, that's which residual paint, you see. That's one of the daft ideas, but that's what they say. But the rig specification, section 2, Neptune 985A, says you're not to weld anything on there without removing the paint from where you're going to produce a welded joint. So presumably they must have done that. But even so, if they didn't, right, how did paint get there? Now let's just finish the commentary on that. And then, so right, maling is the Norwegian word for paint, and it shows the position of the paint inside the joint. The answer to the question is that the as-welded insert joint had inherited hydrogen-induced cracking phenomenon derived from the welder applying the MMA process, not in accordance with a qualified weld procedure. Because on this qualified weld procedure, it tells you everything to do to deliver the common objective, which I showed you earlier. Evidence of these hydrogen-induced cracks can be seen in position 85, which is what you've just seen. That's there. You can see we've just shown you those. Evidence of these hydrogen cracks can be seen in position 85 in the macro sections that you've just seen. One can confirm that the crack observed at position 85 is hydrogen-induced by its profile. For example, that is, if it were part of the early stages of the fatigue crack mechanism, it would be staggered in profile due to these beach marks, etc. So it'd be like looking at the side view of a staircase. It doesn't have that profile. And its position is it's inside the pipe, the insert pipe. It's there. It's not on the crack propagation surface that's being created. A conclusion from this indisputable evidence is the insert joint was not inspected as required by the rig specification Neptune 985A. It's one of the reasons why it was never inspected. Because if it was, they would have attempted a repair. Well, the macro sections in here, you've just seen, there's no evidence of repair. Nothing. You'd have seen it etched, the etching would have revealed the extra runs they were put in to repair the joint. Right, so we got to work out and reason why paint was found on the inside of the hydroform fillet welded joint. You know, got all these arguments. Oh, it was painted before, and and it was invaded by a UFO, and the ETs came along and painted it, without us knowing about it, and all this crap. So you consider the welding of this hydroform fillet welded joint. So you consider, I shall use a better slide than that. You consider when they push the pipe through to house the hydroform mechanism, this pipe, either side of the wall of the brace, right? You're about to weld it now. Apply the manual art process. So, right. So we're about to weld it. Consider the temperature conditions whilst this fillet weld is being completed. So at the end of the rod, whether you're welding at that position or that position, this rod, this 5mm diameter rod, there's an arc length there, right? In that arc, the surrounding arc temperature in the fillet joint area would be on average 10,000 degrees centigrade. And it creates a liquid weld pool, which is at 1,600 degrees centigrade. And in the adjacent, what we call the heat affected zone, that's these little black areas here. Just what we call the heat affected zone. The heat affected zone, which doesn't get melted, that's this black area, it's extra black here. See, there, and there. In that area, it goes through a thermal cycle. It doesn't go liquid, it remains solid. but it goes through a thermal cycle to a very high temperature and comes back down to room temperature. Now, the average temperature in that area is 900 degrees centigrade. Right, so in the heat phase it's 900 degrees centigrade. Now, do you think paint can survive that? No. No. So paint cannot survive those temperature conditions. The only way this paint could be in that position in the fillet weld is if the fillet welded joint was cracked in the as welded condition in the shipyard in 1976. This joint was not inspected in the original as welded condition in 1976. It was just painted over before the rig was towed out to sea. So that was a managerial decision, engineering decision, you name it. Oh, get it, paint over it. They'll never know, will they? That's their attitude. They'll never know. They'd know the consequences of sending a a well-cracked fabricated rig to a position. They know what's going to happen, premature failure. So do these people, this is where I might say something upset you, do they really care about the consequences of the workers on that rig?
Obviously not.
No, they couldn't give a damn. They're only interested in this, in your pocket. That's all they're interested in. They just couldn't care less. So that knowingly, they sent, I'm sorry, but your relatives on the rig, knowing it was going to fail. What sort of people are these people? They've got the minds of an ice cube. They're inhuman. They're scum. It's impossible for any other opportunity for the paint to be incurred in this position in the hydrophone joint. It's impossible. So that's why this is 100% indisputable evidence. It's not 99%, it's 100%. The rig was in a failed condition before being towed into position in the North Sea, which makes the official line of which we mentioned earlier, that there was nothing wrong with the rig when it was towed into position, an outright bloody lie. And I'm using language to shock you. So when you deal with these people, which you may have to do eventually, you've got to be forthright and assertive. You don't take any crap from them whatsoever. Because if you sit there passive, they'll just run the roost over you and they'll continue with this cover-up. And let's face it, they've been successful for over the last 40 years or more. They've been successful, haven't they? So that's why it's a failed condition. So just keep that in mind. Don't jump to conclusions just for the moment. It's in a failed condition. Right, what are we at now? 40? 41. Are we at 41?
Yeah.
Right. Right. The paint on the fracture surface of the hydrophone insert joint proves beyond all doubt that the Allexander Kielland Platform went to sea in a failed condition. I'm going to give more detail about it in a minute. This revelation means that we must revise the date of the Alexander rig failure from March the 27th, 1980 to March 1976. That is and on the day it was completed in the shipyard at the firm CFEM in Dunkirk. So that's fact. Okay? We can now ask the question, would the braced D6 we've got that right, haven't we? Braced D6. Yeah. Have gone on to fracture in service if it had been welded in accordance with the qualified weld procedure with a qualified welder and then the weld joint inspected? Would it have gone on to fail? And the answer is no. You may now ask, where is the proof of that proposed fact? What it can be observed on the photograph is the hydrophone insert still attached to the brace D6, which is slide 35. The proof of that is the fact that the drain hole, as I've mentioned, did not fail. That's the proof. Because if what I've said is not true, the drain hole would have fractured and cracked as well. The drain hole is the same type of joint, as I mentioned, as the hydrophone insert joint, except through full penetration branch. It must be appreciated that the description of the type of joint means only the geometric arrangement of the product forms at the point the joint is unwelded. This distinction needs to be made and appreciated because the joint can be welded, as we've said, fillet, partial pen, and full pen. In the case of the hydrophone and drain hole, there is a requirement for full penetration welding of the joint, for the reasons I've been giving you. The indisputable argument here can be derived from the logic of the way the brace is constructed. The brace D6, like the rest of the braces, are made up of rolled form plates that are welded full thickness of the plate in longitudinal and circumferential seams to make the tubular shape and any length of the tube, as I've said. Therefore, by straightforward logical arguments, the hydrophone joint should have been welded full thickness as a butt weld, not as a fillet. We're all agreed on that, I think, aren't we? From the mechanical engineer's point of view, when the hole was cut into the brace, D6, to facilitate the pipe insert that houses the hydrophone equipment, the hole is a massive defect now present in the brace. The amount of steel in its area needs to be recovered in the joint by welding the full thickness with reinforcement. I'm just repeating that because it's so important. Right, so we're now at 43. So, as a schematic representation, that hydroform weld, you know, this is a schematic macro section. Okay, so that's how it should have been welded, double-sided, and you've got the full thickness welded and with reinforcement to recover the load-bearing area. Yeah, and in fact that's how they put this type of joint in pressure vessels. So it's pressure vessel technology, right? That's that one. How it was welded, there we are. That's how it was done. These are the dimensions of the products. So the brace is 26 millimeters thick. The insert tube is 20 millimeters thick. And the specification, the rig specification says, when you've got this combination of thicknesses, you have to preheat the joint. And that's to do all sorts of things, to drive the hydrogen off, prevent martensite formation, and prevent gas porosity as well. Which you know about, so don't you? So, how far away from the drain hole is the hydrophone? Well, the answer is it's only 270 millimeters away. Did the drain hole anyway during the collapse incident? Did the drain hole fail anyway during the collapse incident? Answer, it can be seen not to have failed or cracked in any way. Why was this observed to be so? The drain hole had been welded full brace thickness in accordance with a qualified weld procedure, welder, and appropriately inspected to the class 3 requirement. The class 3 requirement is just visual and possibly dye penetrant or mag particle surface inspection. There are 3 classes of weld on the rig, class 1, 2 and 3. Class 1, the welds are radiographed. Class 2 is 10% radiography. And class 3 is just visual and surface inspection. But all 3 classes of joint give to weld with a qualified weld procedure. It says so in the specification, 985A. It says so. So if you don't do it, it's bordering on a criminal offence. The drain hole is only 2 centimetres from the position of the welded joint, which is no distance at all, and why the drain hole would experience the same stresses in service. And it's a fact that this joint didn't fail. The hydrophone joint was regarded by shipyard engineers and management as a low-stress joint for convenience, possibly to be only instrumentation. That's what was said to me when I went to that meeting in Stavanger last year. Mainly as a justification not to weld the joint correctly in accordance with the requirements of the rig specification Neptune 985A. This was, and is nonsensical as an argument, and a disastrous position to be adopted, proven sadly to be not true. A fillet weld has little or no fatigue resistance when compared to a butt joint. The hydrogen failure proves this point. You know, to put a fillet weld on that hydrophone joint, you might as well have shoved chewing gum in there. Useless. So I'm sorry to have to put it to you like that. What are we at? 45? 46, we're not far off there now. Right, we must now ask the question, what was and is the Allexander Kielland platform? The answer will improve understanding of what was going on, if we may express matters in these words. All one is describing, when you talk about the Allexander, is, I've mentioned this before, is function. The Allexander Kielland platform is a welded structure beyond all doubt. But it's required to function as an oil rig or a flotel. The way of reasoning facilitates one to determine that welding is the most important action that needs to be implemented correctly. Otherwise, the desired function cannot be realised. The Allexander Kielland structure is a welded structure that functions as an oil platform. This is what it is, it's fact. Question. From all aspects of welded fabrication, how do we ensure to the maximum possible the welded Allexander Kielland structure will function to the design requirements without premature failure while in service? Well, this is the role of a contractually binding weld fabrication specification, Neptune 985A, which makes it mandatory certain actions that must be carried out on a welded fabrication. This specification is Neptune 985A, that's one of its functions. The way the welded fabrication specifications operate is because they are designed, written, constructed, and then function by stating where in all aspects the acceptable imperfections and the not acceptable imperfections to be permitted in the welded joint. So it states permitted level faults, not permitted level faults, and that's in all fabrication specifications in the world, and none of them accept cracking. It is important to establish at this point that the fabrication specification for the rig, Neptune 985, does not allow permit in any form of cracking to be present in the welded joints of the structure. Section 2 of a document which is 1,300 pages long. We need to look at section 2 of the specification, which deals with all the welding failed condition, non-compliant to specification, and therefore could not receive, section 2 of the specification, which deals with all the welding failed condition, non-compliance to specification, and there could not receive or be given a certificate of seaworthiness. So that one of the functions of the specification, Neptune 985A, is it says if you weld it in accordance with that requirements, the rig will be seaworthy.
Be insured.
To be insured. So, just to make a point here, what instructions must be in place to fabricate an oil platform? Oil rigs used in the North Sea are usually designed and fabricated in accordance with the ASME code. That's what they usually are. It's a design code as well as a welding code. What is needed? We must have qualified weld procedures They're being developed by empirical science methods, trial and error, and thoroughly tested to the specification requirements. These specifications work by stating the permitted and not permitted level of imperfection. The fabrication specification for the Allexander Kielland Platform, Neptune 985A, makes it mandatory that these relevant weld procedures are qualified in accordance with what is called ASME 9, which is part of the ASME design code. Second, we must have welders to weld fabricate the component parts for the rig, who have been trained and qualified by testing, coded, in accordance with the established and qualified weld procedures, so that the appropriate amount of energy is pumped into the joints with the relevant physical application techniques. So we're going back to what welding engineer is, pumping the right amount of energy into the joint. They do this qualification of the welder, again to ASME 9, which is part of the ASME design code. Now, the spec Neptune 9858 says, that's mandatory. And all welders have to be coded, and all joints have to be completed in accordance with a qualified weld procedure. Mandatory. If you don't, you are non-compliant and you're essentially committing a criminal offence. Right, so here is a little summary from what Neptune 985 section 2 says. It states the requirements that are required in Neptune section 2. All the weld procedures and the welders are to be qualified in accordance with ASME 9. It states that categorically. In the articles 1, 2 and 3 of ASME 9, regarding weld procedure and weld performance exception criteria, any form of cracking detected in the test pieces is not acceptable. The proposed weld procedure would then be rejected. You're not allowed to use them. It also says preheat of the carbon steel is required at a plate thickness of 30 millimeters. Well, this is it's a gaff in the actual spec. What they should say is that they should quote what's called a combined thickness for the joint, and that could be anything. But as long as you take it, the combined thickness of the joint, if it's greater than 30 millimeters, you have to investigate preheat in the development of your procedure. But that's a bit of a gaff in the spec. That all basic electrodes to be baked at 300 degrees C. Wow. But it says that. So was that crowbar and electrode baked? Unlikely, David. It could have created hydrogen-induced cracking.
No chance.
No chance it's been. See, so these are all things that say they never developed a qualified weld procedure just for that fillet weld, which is wrong. But to weld a fillet weld correctly, they've not qualified a procedure. They're not complying with the specification requirements. Manumetric electrodes are to be the appropriate size for each individual pass or passes. Weld preparations are to be cleaned and dried before the application of the welding process. All this is stated in that spec. All welded joints must not show any evidence of cracking. On the application of the required NDT class 1, 2 or 3, in any of those classes of joint on the rig, I mean, it's an understatement, cracks are not allowed. But it says, that's what it says, cracks are not allowed. Classification of welded joints 1, 2 and 3 only determines the extent of the NDT, which I've just mentioned to you, that's all it does. All classes of welded joints on the rig are to be welded using qualified weld procedures and qualified welders. It states that bang, 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 mandatory. Now here's an interesting point. This is when we now start to think of possibilities of fraud here. In section 2 of the rig specification, Neptune 985A, it names Lloyd's Register to do the final inspection of the whole thing. So they've got to look at every joint. They've got to look at every report of every joint that's been inspected. And they've got to make sure it complies with the acceptable level of imperfection in the spec and the not accepted level in the spec. They've got to have done it. And write a report so that they can make submissions to get a certificate of seaworthiness. Because if you don't get a satisfactory report from Lloyd's, they can't get a certificate of seaworthiness. So it's going to remain in the dockyard. So we're required and responsible, the company Lloyd's, we're required and responsible for inspecting all the welded joints on the completed rig. But also the shipyard, CFEM in Dunkirk, they're responsible for the actual construction. So you've got both parties responsible for ensuring that the welding is carried out to Neptune 985 Section 2. And also, you know, all welders have to be coded to ASME 9. They're not allowed on site, not allowed in the shipyard unless they're coded. So that is a wow. Did Lloyd's Register do what they're supposed to have done? I think the answer is no, isn't it? Where are we now? 48?
Yeah.
So we're just further content. Neptune 985 Section 8 continued. The full range of acceptable and unacceptable imperfection detected are tabulated, and at the top of the list of unacceptable imperfection are cracks, and it's called Table 1 in the specification. This latter imperfection is all we need to concern ourselves with, being able to state when the rig failed. We need to concern ourselves with the cracks. All the indisputable evidence points to rig failure in 1976, when it was completed in the shipyard, and not 4.5 years later in the North Sea. This, as we're all beginning to realise, is fact. Question. Because the evidence establishes the rig went to sea cracked, then how did the rig owners get a certificate of seaworthiness from Lloyd's? Evidently Lloyd's Register of Shipping Inspection did not carry out their mandatory required inspection of all the joints, and especially joints like the hydrophone joint. A valid certificate of seaworthiness is required for the rig to be submitted to the floor of Lloyd's, say in London, or other similar facilities, so that the underwriters can bid for the insurance. That's the first thing they ask for, isn't it, Wayne? You know, they stood there, right, want to insure this rig to be thrown out to sea, where's your certificate of seaworthiness?
Was it 100% Lloyd's?
Yes, oh yeah, it's Lloyd's, yeah, they are named in Section 2 of Neptune 985A.
Right.
They're named,
Yeah.
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 So, it's similar to if you build a civil aircraft line, you've got to have a certificate of airworthiness, haven't you? Yeah, before it can fly commercially. That's just similar in principle. Similar in principle. Because it's so small, this cursor, I can't see it. We go. Right. So now I'm going to ask the question, what then was the defective origin of the fatigue crack propagating mechanism on the hydrophone joint? But don't forget, it's not necessarily the actual fit, that when it cracked and fractured, it not necessarily brought about the failure directly of the rig. It could have been a combination of things. Other braces could have failed before that, but it doesn't matter which brace failed first. It doesn't matter. I'll show you later why not. So the slide we've shown you, the slide shows the early stages of fatigue crack propagation around the brace. I've called them chevron stroke beach markings. From analysis of the fatigue features on the surface of these markings, they point backwards to the source and starting point of the cracking phenomenon. That is the position of the fillet weld and the welding derived defects therein. To repeat, the authorities wish the general public believe and accept that the fatigue cracking mechanism was naturally derived from the rig being in service. This is what they maintain. And so absolve themselves of blame. They have managed to deceive everyone to this day, relying upon the general ignorance of welding engineering. That's what they've relied upon. They've deceived you. It needs to be established that a mechanism is not a cause. It needs a cause to become a mechanism. So the mechanism needs a cause to come into existence. The true cause of the collapse of the Allexander Kielland Platform, the rig, is very subtle. It derives from deliberate malpractice of the application of the manual metal arc welding process, with no qualified weld procedure, no coded welder, and no designated NDT. As a consequence of this latter behaviour, defects were introduced unnecessarily into the welded joints, such as the hydrophone joint and amongst others, which should be noted like brace DE, the brace at the front of the diagram there. This latter fact now prompts the question, who gave the order or instruction to ignore the requirements of the rig specification in section 2, Neptune 985A? Well, it's the management of the French shipyard. Can't be anybody else, can it? Who signed off the final inspection report, which in particular concerned itself with the rig welded joints and further that they were free of cracks, so that the French shipyard and rig owners could be given a certificate of seaworthiness? So who signed that off? Well, it's got to be Lloyd's Register, hasn't it? Who therefore doctored the inspection evidence and made a fake certificate of seaworthiness? Well, Lloyd's Register of Shipping were named as the inspection company to provide the necessary final inspection required by section 2985A. They are named in the specification. Right. So now we're coming to the conclusions now to be drawn. And I'm going to explain this failed condition as well. Explain that. The true cause of the so-called collapse of the Allexander Kielland oil platform is to be obvious and yet very subtle in nature. Don't forget, it's not a collapse, it's a capsize. It capsized at the end of it. The obvious part of the true cause, which permitted a series of domino type incidents to come into being, and which then ultimately led to the platform capsize. It was deliberate non-compliance on behalf of the French shipyard with section 2 of the rig fabrication specification, Neptune 985A. So it's in a failed condition as welded in the shipyard in 1976. And then we observed lots of subsequent manifestations. like a set of falling dominoes, where the final domino to fall is, well, it's the one before the last is the leg falls off, then the remaining 4 legs capsize. But I want you to visualise this, is that it failed, it was in a failed condition in the shipyard as welded in 1976. All the other subsequent manifestations that people are talking about it, as you proceed towards the final capsize, they are all manifestations of the failure. It's appearing in different guises all the way along. So the capsize is a subsequent manifestation of the original failure. So you're stretching in your mind an elastic band of failure. It's the same thing, but in different guises as you go along as time goes by. So that if you correct the true cause, which means you weld the joints correctly, will any of all these subsequent manifestations occur? And the answer is no. Because if that wasn't true, they wouldn't be able to weld these rigs together, would they? They'd all fail, wouldn't they, in some manner or another? On various joints of the rig, welds were carried out without reference to qualified weld procedure, non-use of coded welders in accordance with ASME 9, and no application of the mandatory NDT, derived from the joint classification of section 2985A. All this evidence was confirmed by the evidence of there's no weld repair on the hydrophone joint. There's no evidence of repair. These welded joints at which the hydrophone was won were therefore full of unacceptable defects, cracks being the most concerning. And if the weld is cracked, it's not welded together, it's in a failed condition. These cracks in these welds were introduced as welded in the French shipyard during rig fabrication and construction in 1976. If the as-welded structure of a fabrication is cracked, then it has by definition failed. In a crack, there are 2 surfaces of atoms that are not bonded together. Hence, a joint in this condition is technically not welded. So that one can conclude with 100% certainty the rig failed in 1976 in the French shipyard because the 2 surfaces of a crack, the atoms, they're not bonded. The ultimate capsize of behaviour of the rig is the final physical outcome derived from a series of subsequent manifestations over time in service of the earlier failure of this cracked as welded condition. Think of this as stretching of the features of the original failure over a set of domino events. Okay, so you get the failure in the shipyard, it's in a failed condition, and then subsequent manifestations of the failure happened like a falling set of dominoes. And the final domino is what's called the outcome. But it's still part of the original failure. It's the same thing, but in a different guise. So, proof of welds, like for example the hydrophone inserts, that they were cracked as welded, is 100% indisputably confirmed by the Investigation Commission finding paint on the inside of that joint. That's proof that when in the as welded condition, some of these welds, they never bothered inspecting them, a lot of them were cracked, but they just painted over them. Because the thinking of this disgraceful management is, when you've painted over it, can you see the cracks? No. They'll never know. Sadly, yes we will. So, I'll just go over that again. Proof of welds, like for example, the hydrophone inserts, that they were cracked as welded is 100% indisputably confirmed by the Investigation Committee, finding paint inside the latter joint. That is more specifically in the void created by the double-sided fillet weld. There is only one way liquid paint could get into this position, It is impossible for paint to find its way to this position any other way. It is impossible. So this paint they found inside in the joint, found by the original investigation committee, but they didn't know what it meant, did they? You do now, don't you? Right? And that's the evidence. That's the killer blow. And Wayne, you've used it already, haven't you? Well, who gave you that nasty phone call then? Who was that to give you that nasty phone call?
Dick,
Oh, him, yeah. Right. Yeah. Yeah.
suitable surname.
So that he came out with the official line of crap, right, didn't he? And you said, well, how did paint get inside the joint? He put the phone down on you, didn't he?
Did he?
Yeah.
See?
See, so you see, use this evidence. You know, these people come out with the bullshit, right, trying to deceive you. They've had it.
Yeah.
So it's, the way I express it in these situations, and I do a lot of this work, I express it what you do is, you scoop up a truth custard pie and you go straight in the face of your opposition. A truth custard pie, they can't answer back. The truth is the truth.
No,
Facts are facts. Right. Two. That's right, we're just carrying on with the conclusions now. I told you that there is this subtlety to it. These cracks in the wells confirmed that no qualified well procedures were in use, because preliminary well procedures assessed and tested to ASME 9 do not allow the presence of cracks. The Allexander Kielland rig well fabrication specification 985A, section 2 table 1, does not allow cracks in the production welded joints, which confirms the cracked joints were not inspected by welders, their supervision or Lloyd's register. These type of cracks, hydrogen-induced cracks, are visible on the surface of welded joints and are extensive in their features. You can't miss them. You just can't miss them. And if you use dye pen, it'll shine out like there's no problem. Hydrogen-induced cracking is confirmed and derived from experience gained in welding fabrication by welding engineers who are carrying out welding development, qualifying weld procedures and working on and testing welded products in industry. Just one thing about hydrogen-induced cracking. Somebody might say to you, oh, well, you've got to wait 48 hours for detecting hydrogen-induced cracking. No, that's wrong. That's just an inspection safety procedure where if potentially the joint can give you hydrogen-induced cracking, you're advised to wait 48 hours before to see whether you can detect it or not. But there's no time limit on this. I mean, myself and my colleague there, if I mentioned the word gilligators to him, where we were welding blocks of steel this thick, they were welded without qualified weld procedure, weren't baking the electrodes. When they finished the welds, cracks 20 foot long, immediately. You have to wait 2 days for it. You see, all that is an inspection safety feature that if it potentially could generate hydrogen cracking, you wait 24 hours to inspect it. That's all that means. So don't let anybody throw that at you. Further evidence of hydrogen-induced cracking can be observed in the as-welded condition from the macro sections taken from the remaining fillet weld carried out by that gentleman that Elsa Tungland mentioned to us. On the hydrophone insert, they were still attached to the brace D6, which is figure 7 in my paper and slide 39. We can now conclude that the required defective origin for the fatigue cracking mechanism to come into existence and operate is man-made and not natural from service conditions, as inferred by the French shipyard and other interested parties seeking to cover up the truth. That's what you should take from that, is that just the example of the hydrophone insert weld, that fatigue cracking mechanism, because they took macro sections of the original weld done in the shipyard 1976, that shows you that the defective origin is man-made. It's not from being in service, which is what the French shipyard have managed to convince people. Oh, there's nothing wrong with it when we towed it to position in the sea. It's fatigued naturally through service conditions. And they would be blaming the operators of the rig. Oh, you're abusing operator in the rig. They moved from 10 chains to 8 chains. You know, all this sort of rubbish. All right? So, right, the fatigue cracking observed on the hydrophone insert valve is therefore, it's only a mechanism. It's not a cause. A mechanism is not a cause. However, it requires a cause to come into existence. So I've shown you that from all points of view, including the metallurgical point of view. The defective origin, which all fatigue mechanisms need, in this case, is provided by the application of the manual metal arc welding process without reference to a qualified procedure qualified to ASME 9. However, the subtlety to this conclusion is who directed the welder to be non-compliant to the rig welding fabrication specification requirements of Neptune 985A. I'm sorry if I keep saying that. The answer is yes, it was the management of the French shipyard in 1976. And we therefore conclude that they were to blame for the collapse of the Allexander Kielland Platform. Oh, yes, they were. The final slide is what I'm going to give you some recommendations. This is just now I'm giving you an opinion now. I would recommend that you do not pursue a new inquiry, because the blockers will use it against you. They'll delay you yet again. All right? There's no need for it. All you need to do is present this information. The blockers will insist everyone goes through the examination of all the harvested data before. But I've told you that there's 10 years worth of it in archives, which will take you that long just to read it. There's stuff in this closet as well. We can't on to 2052. So, just going back to this information, what I've shown you that what this failed condition means, that the failed condition stretches over the whole lifespan of the rig. So that all these people preoccupied with what's happening in service and all this data that they collected, it's just worthless. You don't need to know what's in there. You don't need to know what's in that closet either, because you know, if it was welded correctly to the specification, none of that would have happened. It's irrelevant, completely irrelevant. They'll throw it at you. Oh, we're going to go through all that again, haven't we? And spend another 10 years looking at that load of rubbish. But you hit them with this. It was failed as well in the shipyard. 100% indisputable. They can't argue against it. And the big sort of weapon you use is paint inside the joint. How did it get there? So your paint in the shipyard can withstand an arc temperature of 10,000 degrees C and a liquid whirlpool at 1,600 degrees C and a heat effective zone on an average of 900 degrees C. Oh, it's a wonderful paint, isn't it? So anyway, please note that the amount of this data that's in the archives in Norway will take you 10 years just to read it. Further, they would then completely scuttle your efforts by stating that there is data stashed away that cannot be accessed till 2052. I think, is it 2052, Wayne?
Yeah.
Yeah. Therefore, do not accept an offer. This is just my opinion. Therefore, do not accept an offer to reopen the inquiry.
What about a British inquiry? Anyway.
Yeah, well, just let me finish this and then we'll go to question time. Right, okay. I'm saying a means of releasing the truth regarding the true cause of the collapse must be sought to replace another inquiry. Again, this is just my opinion. This is my opinion. use must be sought from the outlets of information such as TV, the media. Mind you, TV should be relegated to as we've said today. The media, the House of Parliament, YouTube, computer platforms such as Spotify, a direct approach to the Norwegian government. I'm just making suggestions there. Some of them may be rubbish. Or roundtable discussions with myself, with the lawyers or whatever. You have discussions. Because I can't sort of, go like that and say what you should actually do. But that's my opinion. Okay. So that's the end of the second stage of the presentation. We now throw it home to question time. And you can ask any question you like, but I don't know the lottery numbers, I'm sorry. Okay, so away you go.
So what's your feeling on a British inquiry or panel of experts from Britain,
Like yourself.
like yourself,
Yeah,
investigating? Again, you come to the same conclusion, but
yeah,
when we find things.
yeah, but you've got to examine this evidence. You
Yeah.
don't want to only up to any, all the other evidence is a waste of time, it's worthless.
Yeah.
And your opposition will use it against you to delay you. It'll be a delay tactic.
Cloud of judgment, isn't it?
Yeah. So I don't mind discussing this with other experts,
Yeah,
but it's got to be about that information because that's the truth.
yeah.
That is the truth. Okay. So you see the way that this, to get this question taken, the way they deceived you is that they've had it established that the rig was towed into position from the French shipyard into the middle of the North Sea, and there was nothing wrong with it. And it had been given a certificate of seaworthiness, which it shouldn't have been. That's where the fraud has been committed. Now the lawyers must make, well, it must be meat and drink to lawyers. That.
Well, yeah, but they're not at the technical side yet,
No,
but obviously.
Yeah.
That's where
somebody's doctored the certificate. Yeah. So, in other words, they've conveniently neglected inspection of some of the wells. You see, and they've said, visual inspection has been carried out and completed. The wells acceptable when they weren't.
Wouldn't you think, Dave, that picture there of the wells, yeah, that was done before he went to sea. Wouldn't you think that was evidence just in itself that?
No, the macro sections. No, that was in the failed condition.
Right, okay.
The failed
that
race.
was before he went to sea.
Yeah.
That wasn't took before he went to sea.
Yeah. Well,
After.
I've through, is it Shania Vaughan? Right. I spoke to him and he said he knows welders who are still alive
Yeah.
who worked on the rig, and they said, well, we all knew a lot of the wells were cracked. We all knew it.
Did you use the same on, I think they did, on leg one, they x-rayed the wells or something, and then they used the same data for the...
Well, they could have been up to all sorts of tricks. Yeah. Yeah, that's a famous film with Jack Lemmon into the China syndrome, isn't it? When the power station and where they used.
I don't know,
Well, yeah.
on in the comments.
No, that's technique. That's a famous film.
Yeah.
What they did. Yeah, it's about taking wells that are satisfactory radiographically and using the same radiographs to qualify all the others.
Yeah.
And that was a film.
So
that was China syndrome with Jack Lemmon.
That picture that we've just seen with the wells, yeah, three different wells, they were off the Kielland, yeah? They were the wells off that rig.
So,
The picture with the crap on?
Yeah.
Aye,
Page 36 was it?
Yeah.
Yeah.
just that one.
Yeah, I thought he said it
Was
was
it-
in the
if they-
shipyard. He said it was in the shipyard,
Yeah,
didn't
well,
he?
if they're the original photographs of the
I mean
wells,
these.
yeah,
No, that was taken from the wreckage when he was brought into the fjord.
yeah.
And they took
the
three
Kielland.
sections round the original
Of the
well.
Kielland.
Yeah, off the Kielland, yeah.
Yeah, so them wells.
No, it's just one weld. It's just one
three
weld.
sections.
Right, well,
Just
that
three
one-
sections through it,
that
yeah.
one weld has never been done right from when it was made, and that proves it, doesn't it?
Yeah.
Of course it does, yeah. It's indisputable. It's 100% indisputable, yeah. It's the original weld completed in the French shipyard in 1976.
Well, you can't go back, can you? You know what I mean? that hasn't been done right and ended up like that. Because if it was done right,
It wouldn't look like that,
it
no.
wouldn't look like that, would it?
No. It would look like this. This
So
thing
there'd be
here.
no black, would there?
Yeah, it would,
But it happens in a,
in cross, even though that's a schematic,
but that's how
it
should
would
have
etch
been
up,
done.
it would etch up, and these, let me show you,
Is that how it should have been done?
in a macro section,
Yeah.
on
Remember,
carbon steel,
two items
these,
becoming
these,
one.
these
Yeah.
surfaces here, you would see black lines like that between the runs,
Yeah.
because each one of these is a heat affected zone.
So
You have a heat affected zone in here as well,
you would use that.
and
on
in here as
submarines,
well.
yeah? You would use that well on submarines and,
Yeah, oh yeah, this is, yeah, it's this, yeah, and a pressure vessel as well. When you put a branch into a pressure vessel,
Yeah.
right, you have to weld it like that.
So when you build these rigs at the shipyard,
Yeah,
they build them to be one complete structure.
correct, yeah.
And then they're taken to their
Yeah.
place in the sea. So
Yeah.
are they inspected at certain points during the build, or are they inspected once it's complete?
No, they're inspected during the build,
So as each component starts to get,
yeah,
yes.
yeah.
they should be.
Yeah, as each joint is well fabricated,
Yeah.
it's then inspected, yeah,
Right.
right?
So there
So
should
as
be
you go along, it's
documentation on every
all shall be
single-
inspected, the specification says so. But at the end of the day, Lloyd's Register
So then
are the
each-
organisation named to go over the whole structure and verify that visually those welds have been carried out to the specification with qualified weld procedures and welders properly inspected.
And Lloyd's in the insurer.
No. They're the inspection organisation on site in the shipyard,
Right.
right?
So they work-
The insurance part of Lloyd's is the floor of Lloyd's, you know, in that special building in London,
Right.
right? That's where all the underwriters are, with these tall desks, you know, and they all make a bid for the insurance.
But they need that certificate.
But
Where
they
is
need,
the
but they need to see the
certificate? Is that what
certificate of
they
seaworthiness.
looked up, Potentially.
No,
Otherwise,
no.
you wouldn't
I
insure
don't
it,
know, it's not
you wouldn't insure it, would you?
Could be, really, yeah. could
What's
be.
in, what's locked away till
It could- it could
2052?
be, yeah.
Is that potentially where the certificate is?
No,
No?
we don't need to care about it. Your attitude should be, what's in that closet?
Leave it.
Not rubbish.
What's
in the archives? Rubbish.
But where is the certificate then, of the original certificate?
Has it
actually been certified?
What,
Was it
what,
just
they'll
Nigerian?
produce a fake certificate of seaworthiness. They would have had to submit that to the floor of Lloyd's so the underwriters can make a bid for the insurance. They would have to have that in their possession, a document.
So
Yeah.
where's that document now then?
Well, it must be in the record of in the ownership of the insurers of the rig, because they can't insure, they won't insure you unless you can see it, and they've got say the master copy of the certificate of seaworthiness. You have to have it. Yeah. So you see, you know, fraud and all this, the skullduggery that's going on.
Yeah.
Sorry, I'm sorry I have to say that. I really am sorry to have to say that to you, yeah. And the attitude of the management to put your relatives on that rig, it's inhumane. That's inhumane. These people are scum. They really are scum. You know, I'm using this word in front of the video. They are scum. They don't care about anybody else. They've not cared about your relatives in the slightest. They couldn't give a damn. But they would know the consequences of sending a rig that's cracked, it's unbelievably cracked. To say it's ridiculous.
Well, there was talks, wasn't there, that someone was inspecting the cracks for 6 weeks before the rig capsized.
Yeah.
We were going down daily and measuring.
Well,
It was in situ, like it was in operation.
Yeah. Measuring daily because they were getting bigger or, right, okay.
just look at this. So don't forget, it's not important. It's not important as to the true cause of the failure, that whether this failed first or another brace shall we say, we just go back to,
I suppose it's but for the welding failures that the rest wouldn't have happened, would it?
you see, it doesn't matter. You see, that some people say that this brace DE, the one that they melted down, not here, they're hiding evidence. They said that failed first. I've met the engineer who's proposing that, and I've said to him, yeah, well, fair, all right, so it failed first. So what? You know, the failure was in the shipyard in 1976. This is what they don't understand.
Why? Is that another reason why it sunk like 1,000 litres or whatever?
So
In the
the
field.
tube couldn't be.
Well, you see, they think they've hidden evidence, but they haven't.
Right.
You know, they think this evidence is in these archives, which would take you 10 years to read, in this closet, right? Or it's in the bottom of the field. So what? The evidence is there in the commission report, in the photographs. The fact that the commission text is no better than nursery rhymes doesn't matter to us professionals when we look at this. Speak to us, talk to us. Dave found, stated to me the true cause within a minute of me showing that information, and that's no exaggeration because he's a professional, he's a 50-year professional. This is what's going on in industry now. It's absolutely shocking what's going on. Now, a parallel with the Grenfell fire, everything about the Grenfell fire incident is exactly the same as what's happened to this Allexander Kielland platform. With the Grenfell fire situation is, how did that cladding get a fire certificate? It's not fire resistant.
No.
How did it get that? So who's done that, you see? Yeah, that's where frauds come into it, you see. Now that's exactly the same as with the Allexander Kielland plan. Who doctored the certificate of seaworthiness?
Who sent it to sea? Who said it was seaworthy?
Yeah.
Well,
That's Lloyd's Register, yeah. But they would have to make out a certificate of seaworthiness to go to the floor of Lloyd's, which is the insurance part of Lloyd's, right?
Sure.
And they go on the floor. That's in that special building in London, isn't it? Lloyd's there. Where all these underwriters are, you know, with these, have you seen them? They're all in these tall desks. They're up to here, aren't they? With quill pens and all. It's quite funny. And they're the ones who bid for the insurance. That's what they do there.
I think it was Stavanger drilling that owned the rig. Phillips Petroleum ran it, but they got 95% of their insurance money
Yes.
back. Stavanger drilling.
Yeah, because they had it established that the French shipyard weren't to blame.
Yeah.
You see, it was a natural failure from in-service conditions, you see.
If it went the other way, where it was never fit for purpose, they wouldn't have got the 95%. Because it shouldn't have never been there.
Correct, wouldn't have got anything.
So they've maybe, well, what I'm
They've got a
saying,
reason.
they've worked with the shipyard to collect the money.
Yeah, I can give you some other facts now. There are claims by some people, and when I went to this meeting in Stavanger last year, where people were offering, well, I know how it failed, and all, well, I know how it failed, and all this sort of rubbish. There were people there that said, oh, there was something wrong with the design of these five-legged pentagonal structures. But there was no overload. It was always working within the design conditions. So there's nothing wrong with the design.
Well, it was,
Nothing wrong with the design.
they said it was designed not to capsize.
Well, it
Even
wouldn't
if it
capsize
lost-
anyway. It
even-
wouldn't capsize.
Even if it lost a leg,
Yeah,
then it did.
yeah, it didn't because the brace fractured. It's all the water would go inside the tubes, wouldn't it?
Right.
And it would then tip over, wouldn't it? Then tip over. So, and another thing they maintain, I don't know why they say this, but they say, somebody was saying, the two guys that were on the commission, I think said, we abused operation of the rig, it was malused. Well, mal-operation of the rig means overload. Was it overloaded? No. So what they're admitting to, they've not done anything wrong either.
They're collecting the money from the insurance, aren't they?
Another thing is that one guy was saying in this meeting, he was saying, we went from 10 chains to secure it to the seabed to 8, you see. So I said to him, all right. He said, and that's why it was overloaded. We've got different stresses and strains going from 10 to 8. So I said, well, all right then. Well, you know, you've got to prove to me it was overloaded. Because overload, it's immediate. You don't have to wait for it. It goes like that. Or genuine overload.
No sign of it, was it?
But I said it hasn't. And he'd no answer for that. He got really aggravated about that. And he was one of these people, he starts off, you know, bouncing around. Oh, there's nothing wrong with the welding. Nothing like this, running up and down like this. Nothing wrong with the welding. Oh, no, it's fine. Welding is always okay. That's what they all said. 3 of them said that. And then we had the priest, right? The priest saying it was the 7 deadly sins. You know, on the agenda of it, he's saying it failed through 7 deadly sins. I'm sorry, but the guy, listen, the guy, we all know who that is. I mean, I don't like mentioning names, but he got up and said he used the 7 deadly sins, 7 deadly causes of failure. But the point is, he's a priest, right? Fair enough, if he's a priest. But what does he know about welding engineering?
I think everyone.
Nothing.
has their opinion.
And what's he doing? Trying to do a failure analysis? It's ridiculous. He's like an electrician trying to do brain surgery. It's ridiculous.
What was the reason for Bruce being there?
'Cause
He took charge of the families, didn't he? Yeah.
Right, okay, so he had involvement, it wasn't
Yeah.
just.
Yeah.
Oh, no.
Yeah.
Everyone had the chance to say why they thought, you know.
Right,
Can I say to you, anyway, he's passed away now. He unfortunately died of cancer, but it's not so long ago that. And but anyway, at the end of the meeting, he was running this meeting that we had 12 months ago in Stavanger. He got up and said, one of the real problems. It was a very profound statement he made, and with all credit to him, he said that the original investigation was closed, behind closed doors. He said it should have been open. And I'm pretty sure I got up and said, sir, that is a very profound statement. I congratulated him afterwards anyway. I congratulated him on that. But the rest of what he came out with, I'm sorry, but
nonsense.
I'm sorry, I said, you know, he can't, I know.
No,
He can't, you know, he was a bit deluded, you know, he was very strongly religious, you see, so he thought he could, well, I'll teach the flock how we can, you know, work out how this thing failed. He can't do that. See, that's been the big problem. Loads of people involved who shouldn't be. They should listen to the professionals involved. But they haven't, you know. But anyway, I did congratulate him on that, you know, so I'm not the awful person you might think I am. You know. So there's nothing wrong with the design. They've not maloperated the rig. There's no evidence for it. None. When they went from 10 chains down to 8, all it could have done.
well, they run the chain through the rig, didn't they?
Yeah, but all it could have done is just accelerated a bit the fatigue life of some of these joints. Yeah, there was more than the hydrophone joint failed. More than that. Far more than that. But in what order? It doesn't matter. It doesn't matter because the original fail condition is the welds were not welded in accordance with weld procedures. No coded welder and no inspection. And these welds were full of hydrogen-induced cracks. So they're in a failed condition. And all the rest of the manifestations are of the same thing. So that the actual final, the leg falling off, which is the next to one last domino, the leg falls off, which is by fatigue, and then the capsize of the four-legged structure. That's the final outcome of the same thing. It's just different manifestation, different guises of the same thing.
Not having.
Single-sided.
Yeah. So I hope you see that. You see that this failed condition, what it means is that you'll see different manifestations. If I can explain it, but to get a better understanding, is if you, it sounds a bit gorish this, but say that, for example, you get your liver fails, okay? So you've got a failure of the human body, right? And you're not likely to live very long. When a liver is seriously failed, no, it's cirrhosis, is it? Cirrhosis, right. What you'll get, before a human being passes away from that, sorry to sound like this, but you'll get manifestations of the failure. Goes yellow, might go blind, kidney disease, but they're all manifestations of liver failure, you see? And that's the way to think about the failure of the rig. All these things they keep talking about, including the final outcome, they're all manifestations of the initial failure, which are the cracks in these wells, these hydrogen-induced cracks. And the proof of that is that if they're welded correctly, which the drain hole proves, if they were welded correctly to the spec, which a lot of the wells were, right, would the rig have failed? And the answer is no, because it's not been overloaded.
Yep.
It would have carried on. There may have been a little bit of fatigue of the joints, but it would have survived the design service life. But the other thing I just wanted to point out here is that the inspection during service, right? Don't forget here. This crack, before they got the the guy having his bacon and eggs, and I heard a loud bang, so the crack had propagated virtually half around the circumference before you got the tear off, the bang. How is it they didn't notice that, for goodness sake? And I'm pretty sure that the way they inspect in service, what they do is they'll do some outside surface inspection. They'll use divers as well to do inspection. But they'll go inside these tubes because it's a massive structure. It's massive, so they can go down the leg and then into the braces and have a look. It doesn't stop them from doing it. They must have done it. So how did they miss that? A crack that size. How did they miss it?
When they locked us, was there a hatch left open or something? And that caused the flooding of one of the legs?
Yeah, well, yeah, I mean, to be honest, that's a separate issue. That's not the cause of failure. Right. It's not the cause of failure. But if some of these tubes, these braces, when they're connected to the leg, they would be like doors that they close and this sort of thing. But they're accessed for inspection as well.
Yeah, of course.
But if they left some of them open, well, in normal service, there shouldn't be any water in the legs or the braces, should there?
Well, of course.
Shouldn't be any water in there. No.
I was thinking it was,
so
if these hatches are watertight,
yeah.
then would the bracing, was the bracing absolutely catastrophic for the leg to go?
Yes, it would do. Yeah.
So it doesn't matter if it's watertight or not.
No.
It's
a minor issue. It's not relevant. No. Yeah, and that's what you've got to do. You've got to discard all this irrelevant information because they'll use it against you to try and deceive you, which is what they've done already. You've got to stick to this, and with paint inside, you say paint inside that joint, and they're smashed. That's a hit in their intellectual solar plexus. Wham! Wayne's used it already successfully.
Put down. So what's your next move with that one?
Yeah. That's what you do. You don't bother with anything else. You don't bother with it.
With him for a while.
Yeah.
And we're going to be ruling and leave because
No, it's all right.
we're going to have some kids.
Don't forget everybody. Is that you can get my email address off my website,
Yes.
EJF Consulting,
Mhm.
and if you've got any further questions, just email me and I'll answer them.
Yeah.
Right.
Thank you. Nice to meet you all.
Right,
Thank
see
you.
you all.
See you later.
I'll get back to the kids and everything.
Take care.
Okay. See you again.
Thank you. Thank you. See you soon.
Yeah. Thank you very much. See you later.
Thank you.
See ya.
Thank you.
Take care now. Take care now. Yeah.
Bye.
Yeah.
On there's I think what you need to we've got Hook's Law in Young's Modules.
Yeah.
I think a couple of short sentences that explain what Hook's Law is and how it's relevant to this. To this.
Yeah. Well, do you want to know? Do you want to know what that means? Hook's Law.
Well, yeah.
Oh yeah,
he's never
physics
listened.
side.
Yeah. Well, Hooke's law is when you actually stress a piece of steel, you pull it and stress it, up to a certain stress, that's load per unit area, if you release that stress, it'll go back to its original dimensions.
Right.
That's called the elastic behaviour of the steel. But if you go beyond a certain stress, which we call the yield point, okay, the yield point, the stress is so great that it permanently deforms the steel.
Stretches.
Right, so that if you release it at that point, at the first startup of plastic deformation, if you release the stress, it won't go back to the original dimensions. But if you go so far with stressing it in the plastic region, eventually it will just snap and fail. Yeah,
The balloon burst.
yeah, that's Hooke's law.
Yeah.
See, so and with Young's modulus, what Young's modulus means is that you can't, in a steel, when you stress it, you can't have the plastic deformation, the extent of it, without a certain level of stress being applied. And if you've got a certain level of plastic deformation, that means it's been exposed to a certain level of stress. That's what it means.
So an overload.
Well, no, that's just a relationship,
Right,
that's all,
okay.
yeah. So that you know that if you've plastically deformed a welded component, it's gone out of shape, permanently out of shape, you know you've exceeded the yield point.
Okay.
And you know that the stresses have gone beyond the yield point. Yeah, the stresses, which is the load per unit area. Yeah. Yeah, that's the physics. That's the physics, yeah.
Right.
Yeah.
Good.
But I didn't want to throw too much at you, see, that's the thing.
No. Excellent. Okay.
But so there was nothing wrong with the design, or the declaring of something. Nothing wrong with it at all. Because if there was, they'd made about 12 other rigs like this in other shipyards. They would have failed anyway. They would have failed.
Following the same plan.
Yeah, they would have done it, you see. The rig operator said, oh, well, we abused the rig in operation. Not true, because there's no overload. So you can't abuse a rig if you don't overload it.
So when you say overload, the overload is with what?
You've gone beyond the yield point, well beyond the yield point. So it collapses like a beanbag, goes out of shape, like I showed you.
Yeah.
But that's
Is that
immediate.
because of, did you have too much weight on the platform, I'm presuming, or?
Yeah, all sorts of reasons, yes,
Yeah.
all sorts of reasons, you're quite right.
Well, it's all well and good that they're kind of blaming the people that
Yeah.
sadly lots of lives.
Yeah.
Yeah.
So that, these people, when I went to that meeting in Stavanger, some people were saying, well, we overloaded the rig. And I said, no, you didn't. There's no evidence for it.
They're being made to believe that, then.
Oh yes,
They
yeah,
must
they've been
yield themselves
brainwashed.
then.
They've been brainwashed, or
Yeah.
I think,
Well, it's easy to blame people
I
that's
think
not got
it all
advice anymore,
goes
isn't it?
to the 95% insurance money
yeah,
that they got back when it capsized. They didn't even scrap that rig. You'd scrap that, the metal, wouldn't you? You millions of pounds you'd
Yeah.
scrap
yeah,
when it got sunk.
Just,
yeah. They thought they were
Never
hiding
to
the
be seen
evidence,
again.
but they haven't. They haven't.
No, it's there.
It's still there.
It's there.
Yeah.
because they've already done the research and know.
But you see, those people, everybody involved with that, do they understand welding engineering? No.
No, no.
Which is fortunate for you. That's fortunate. Yeah.
Yeah. So obviously 95% of the money back what they put in and then what they made in profit with
Yeah.
it running. Well, it's quids in, isn't it?
And what I heard when I was in Norway at that meeting, what I heard was, I need to be corrected on this, but I think the management, the owners of the rig, reinsured it for more money.
Yeah.
About, say, 6 weeks before it actually failed or what?
Wasn't that?
Was even that.
Right. So, I mean,
So, I mean,
how suspicious is that?
so everything to discard the truth, there's your technical side. That
Yeah.
was what all lawyers.
Yeah,
Obviously, we've got another side as well going on, yeah, Colin, different.
yeah.
But
Yeah, don't let them distract you away from that. That's the true cause. That's the explanation of the true cause. 100%. Right, well, things like what I've had thrown at me by people talking to me about this. They said, well, what about, they couldn't get into lifeboats. Yeah, but I said, that's a separate issue.
They shouldn't
It's
have
not-
to
nothing to do with the true
yeah,
cause.
yeah.
And how can you get in a lifeboat if the thing's capsizing? How do you get in a lifeboat? So it's a separate issue. But they'll throw it in to the, they'll just say, no lifeboats, oh dear.
Documents up to it in 2052.
It's crap. It's all crap.
I just wrote
It's crap.
everything you need to know.
That's-
Why
You don't
you
need to
hide
know it.
and then
On the
document.
wrong road.
It's unnecessary data.
Uh,
And if you go on this,
It's unnecessary data to true cause, but it could be necessary in something else.
yeah,
Yes,
cloud
yeah,
in your judgment.
so you see, what they said, the Norwegian authority, what they've said is, well, we've done things so that this thing won't happen again. You know, the famous phrase, it won't happen again.
Learn from our
And what have they had? Oh, they've had meetings. Blah, 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 blah. Well, if they don't address the welding, say they said they made a claim to design, oh, let's build it with 6 legs instead of 5, right? Well, if you don't weld it, if you weld it the same as this, that's going to fail as well, isn't it? You know, it's pointless.
Essentially wrong.
It's absolutely pointless.
It's still fake.
Well,
Can I ask a question? I want to put a question. How do you think welders are trained? Where do welders come from?
College.
On the job?
On the job. It's apprentices on the job.
Some do.
Yeah.
Welders come from apprenticeships.
Yeah.
Welders come from being trained by other welders.
Yeah.
Welders come from technical colleges. They come from all different training venues. So if you're being trained by another welder and he's got bad habits, where do you think the bad habits go?
Yeah, the next generation.
And it's passed on and passed on and passed on. This goes on all the time. There's no particular college where all welders go. They're
Yeah.
trained in all different aspects and different ways.
And Dave, I'm
Is there
like,
a
different
governing body
means.
over them all though?
Pardon?
Is there like a governing body over them
Examination
all?
board.
Like
There's sitting girls. Sitting girls train
They
welders.
don't tend to have like training
But not all
colleges,
welders.
technical colleges anymore, do they? It's like online and you go and do a day on
Yeah.
the
So-
job, but if you're learning the wrong techniques.
Some of the attitudes of management are, there's the job, get it welded.
Yeah.
That goes on.
there's
You're a
no-
welder, aren't you? Get it welded.
There's no such thing as a perfect weld either, is there?
No.
No.
no, it can't, no.
There's no
Yeah.
such
It's all
thing.
trial and error, isn't it?
Yeah, there's no, I'll tell you why, right? And I'll tell you why. It's very straightforward. There's no such thing as a perfect weld. That's with no imperfection in it whatsoever. The reason is that atom movement, you know, we're talking about atoms coming together and bonding. Atom movement is completely random. So out of something that's completely random, how can you have order? You can't have it.
So you get,
That's it.
So you
That's the
get-
explanation.
so you get as close as perfect as you can.
Yeah, you work to suppress the imperfection level in your weld that's as the minimum possible in the material condition and in its physical condition.
You've got to get the right chemistry.
But in that practice,
Correct, yeah.
in that practice, you've got to pick the right weld for the job.
Which comes down to
Oh, that's another
chemistry,
thing.
isn't it?
They picked a fillet weld, that's wrong, it should be full thickness.
Foot weld.
Yeah. Yeah, and you know the difference now between a joint and a welded joint. Yeah. That Mr. Dick doesn't understand that.
No, sounds like a right one.
Always,
Oh,
He's very
he's absolute,
Yeah.
you know, I
What
mean,
is his role in?
he just
Where
talks
does he-
nonsense.
he's
I'm afraid.
done a lot of investigation into the topic, and he says that everyone's wrong and he's right, basically.
With his
with
opinion.
his opinion.
Narcissist.
So has he done the research from the Norwegian side of?
Well, he's actually English. He lives
Oh,
in
right,
he lives in Stavanger, and he runs a company to investigate different.
He claims to be an investigator of failed welded structures.
Yeah, and that's exactly.
But he's not a professor.
And whatever you say, whatever I say, and I'm quoting things off people that I've talked to over the last 12 months, and I've talked to a lot of people, and I'm putting it to him, and whatever I said, no, wouldn't come close to agreeing with anything. It was his way on the highway.
Yeah.
Swiftly got to fuck off.
He should be, that'll be edited out, by the way. He's just totally misguided. And I think it's something to do with this, in my opinion.
In my opinion, I think someone's put him up to shooting everyone up, you know, especially us on this side of the water.
Yeah,
Yeah. I've never ever met his work. He's set his suits him very well.
yeah. So you see, you're now armed, and don't forget, you can always email me if you've got questions, you know, and you're going to receive this information.
Yeah.
It's going to be sent to you. But if you've got questions, you can just email me and I'll give you an answer. Yeah. You know, I've tried to keep it so that you can, you know, within 2 or 3 hours you can take it on board.
Yeah,
Okay.
yeah, that's good, yeah.
But if you take it that I've been researching this now since 2018, right, and I've covered all the important aspects. You know, this stuff that's in the archives and in this closet, I'd burn it. It's a waste of time. It's a complete waste of time because the evidence is there.
It is. For the true
Yeah.
cause, it's maybe a waste of time. But for other,
Yeah, the aspects
You don't
of
know what else
the
is
captain,
going
the
on.
captain's
With
logs,
regards
for the
to
true
conversation.
cause,
captain's logs,
for the
they
technical
are
side,
in
maybe not. But for anything else, there could be a use.
Correct. Yeah. So who did what when, right, with regard to insurance or whatever?
Well,
Yeah,
yeah.
fair enough.
Yeah.
But from my point of view, and I'm just
Yeah.
being selfish here. Yeah, that's me.
No, it's interesting that you've got all the
Yeah. Anyway, don't worry. Wade will keep you under lock and key. You know, don't you worry about it. You know, I'm the bad cop.
You're
And
the secret
you
weapon.
can see these
Yeah.
gentlemen. These gentlemen are the good cops, you see, but I'm the bad cop. See.
our trump card.
That's it. Obviously recorded, yeah.
Yeah. Well, it's still going on. So just
Yeah.
anyway, the use of language or whatever, me prancing about,
That's the way now.
that will be edited out.
That's the way.
Yeah, so it's on, all this is on PowerPoint, so I can download that as well, you know, but you won't have the voiceover
No,
with the
no.
explanation.
Absolutely fine.
Yeah.
Okay.
So,
You're doing it
but,
quite well,
you know, it's up to you now, you've got your ammunition now, it's up to you now to use it. And don't forget, the real power punch is paint inside that joint. And that kills all the argument. It kills all the argument for the
There's no
truth.
explanation, is there?
No, you can't, it's impossible for it to be anything else. Unless you've invented paint that can withstand those temperature conditions.
You know, I'll love you to meet you.
Yeah.
I wish you all the best with you.
Nice to
I wish you all the best.
Yeah.
Because you need to be really successful. Yeah, all the best, mate, yes. All the best.
Yeah.
Yeah, good.
Thank you very
Yeah.
much. Thank you very much.
All the best, yes. Yeah, you've got the momentum now, you must keep it going now.
Thank you very much.
All right, okay.
Yeah.
Yeah, yeah, yeah. Yeah, but don't forget, involve me.
Yeah.
Involve me.
First we'll say, get this video out to the social
Thank you.
media.
Take care.
And then
Yeah,
we'll have a look at the evidence. So get this video on. Or to put it on, because this is.
Well, you have to be edited when it's best.
Oh, yeah, yeah.
It's ongoing now.
Yeah.
Non-stop.
Yeah, we'll have to edit me, I'm coming in late. Making the,
I'm gonna get out, I'm not for normal words.
Yeah. I'm not leaving straight away, so.
Before
Before you, we'll have a word.
Yeah,
before you
I
go,
think
yeah.
they're going to take your sandwiches. He was
Yeah.
saying to me before,
Yeah,
he says, you want these? I said, yeah. He said, oh, well, we've got 10 minutes, I'll be moving them.
right, okay, well, go and get
So
our
hopefully
doggy
it's
bags
still
now.
there.
Just whilst you, I didn't mention it, well, something I didn't know. What was the size of the well that was deposited on the hydrophone? What was the size?
It was variable in leg length. It was variable in leg length, but it ended up about 12mm leg length.
So in actual
It was
fact,
designated for 10, and it was 12.
but if you use the principle of the thinner material, that well should have been 20mm.
Correct, yeah. Yeah.
Didn't know.
The whole thing is a mess, isn't it? It's an absolute mess, isn't it?
The one thing that's bugged me is they've got two lawyers or something down in London.
Yeah, there's a set of lawyers, yeah. Yeah.
What are the views of them sort of achieving their objective?
Well,
I know there's sufficient evidence to sort of say, right, this was a bugger up in France.
correct, yeah, that's right.
Yeah. The one thing that you need to put into the ammunition is that you can't fill the crack up with paint and water.
Yeah, well, the only way the paint got in was because they painted over the
Yeah, well, it's
crack wells.
Well,
Yeah.
what I'm getting at is they say that the thing was perfectly all right, but it left the dumping out.
Yeah, because they painted it.
They painted it,
They
yeah.
painted it, yeah. Disguised the cracking, yeah.
Hopefully just covered it up.
Yeah, everything was covered up, yeah.
But this has been going for 40 years.
Yeah. You won't believe the behaviour of these people in Norway. You won't believe it. You know, the prancing about I did there, that's true. That's what they were like. And they were insistent on saying there's nothing wrong with the wall welding's always all right. And then they started going into the stresses and strains while they did so they discarded what I call the macro view. They discarded all that information. You know, they never questioned why is that fatigue crack there on that particular brace? Why is it there? When next to it there's a weld which is the same joint but welders have there's nothing wrong with it. And it's only that far away. And it's seeing the same stresses and strains in service. So why hasn't it failed? Well, it's welded different to the other weld. It's welded different.
And also from the technical point of view, just make sure that your spelling's right. Well, so one spelling mistake, and also the labelling of bleach marks versus the chevron. Chevron marks are for brittle fracture of ductile materials.
Mm. Yeah, but it's fine, Jeff. So it's okay.
Yeah.
But the way the report is written, they call them chevron marks, etc. They call them all sorts of things. Yeah. That's all I was reporting. Yeah.
Okay.
Yeah, it's all right. No, it's okay. It's perfectly fine. Yeah.
Whoa.
Right, I'm gonna
Right.
hit the road, Jack.
Well, I'm just going to have a word with Wayne, and then I'm going to drive back. You know.
I'm gonna drop Jack back at it.
Is that?
So I'm just gonna ring his son.
Yeah.
So,
Outside your place.
Yeah, that's great. It worked all right this morning. Yeah, great. Yeah.
Fortunately, that's his license, so that is the wrong
Yeah. So anyway, thanks for coming. Anyway, oh, you've enjoyed it anyway. So,
that's all right.
yeah, it needed to be done. And you see, these people, they were quite surprised with what I just said. I could see the faces. They're quite surprised what I just said. So I've given them hope. See now, they're not the true cause, they can use it as ammunition. Yeah. There are other aspects, you know, about the insurance, but I'm not concerned with that. I'm concerned with the true cause. That's it. Yeah. Well, they've got, you know, these people got nothing. Nothing. It's all gone to the directors and what have you. It's all gone to them. Right, okay.
When you're leaving, do you have to clock out or anything? Do you tell them or? do
No,
you
no,
just
no,
walk
no,
in?
no, you don't have to say anything, no, you just go,
Oh.
you're fine, okay.
Right.
Right, see you, okay?
All right, be in
Yeah.
touch.
I'll be going about